What if everything we know about the universe is just a small fraction of its true nature? The cosmos, vast and mysterious, holds boundaries that challenge our imagination and understanding. Join us as we journey into the unknown, exploring what lies beyond our cosmic borders and what finding out could mean for humanity. The idea of the edge of the universe can be quite misleading. Unlike a simple box with defined corners, the universe doesn't have a physical boundary that you can reach. Instead, consider the universe expanding much like a balloon inflating. If you imagine the surface of the balloon, any point on that surface is still part of the balloon, and as it expands, the distance between points increases. When we refer to the edge of the universe, it's more about the limits of what we can see, rather than an actual end point. This visible boundary is known as the observable universe. Because light takes time to travel, we can only see objects whose light has had time to reach us since the beginning of the universe, approximately 13 billion years ago. Beyond this observable area, galaxies and other cosmic structures may exist, but they are beyond our current ability to detect them, making it seem as if there is an edge. So, in a sense, while we can talk about the limit of our vision, there is no physical edge where the universe stops. Instead, the universe keeps expanding, and what lies beyond is still a mystery, inviting us to explore further into the cosmos. Scientists define the observable universe as the region of space that we can see or detect, given the limitations of our technology and the speed of light. Imagine the universe as a vast ocean, and the observable universe represents the portion of that ocean that we can explore. This stretch of space is determined by how far light has traveled since the universe began, which is approximately 13.8 billion years ago. However, because the universe is continuously expanding, the edges of this observable portion are actually much farther away than that simple time frame suggests. The light we now see from the furthest objects we can observe has traveled for billions of years to reach us. This means we are looking back in time at ancient light that gives us clues about the early universe. The observable universe is not limited to just the stars and galaxies within our reach. It is a massive sphere centered around Earth, with our planet at its core, stretching out in all directions. While it is immense, it represents only a portion of the entire universe, which may extend far beyond what we can currently perceive. Consequently, there is much that remains unknown beyond the limits of our observational capabilities. Scientists continually seek ways to expand this understanding, eager to uncover what lies just out of sight. The cosmic horizon is like an invisible boundary that outlines the farthest distances we can observe in the universe. Imagine the universe as a vast ocean, and our observations have a limit based on how far light can travel since the beginning of time. Beyond this horizon lies a region that is inaccessible to us because the light from those distant areas hasn't reached us yet. This horizon is significant for several reasons. Firstly, it helps define the size of the observable universe, which is the part we can study and understand. The more we learn about the cosmic horizon, the more we comprehend the limitations of our observations. It serves as a reminder that the universe is much larger than what we can currently see. Secondly, the cosmic horizon also informs us about the nature of the universe itself. The expansion of space is continuous, meaning that regions of the universe are moving away from us. As the universe expands, parts of it may eventually cross this horizon, becoming unreachable. This impacts our understanding of cosmology because it suggests that there may be entire sections of the universe that will forever remain beyond our reach. Finally, studying the cosmic horizon connects to fundamental questions about the universe's fate and structure. It leads us to consider what lies beyond, including the potential for regions of space that could harbor different physical laws or various forms of matter that we have yet to encounter. The cosmic horizon isn't just an edge. It represents both the limits of our current knowledge and the endless possibilities waiting beyond. Light is fundamental in helping us explore and define the boundaries of the universe. It serves as a messenger, carrying information about distant stars, galaxies, and cosmic events across vast stretches of space. The speed of light is incredibly fast, yet it takes time for light from distant objects to reach us. This means that when we observe light from a faraway galaxy, we are actually looking back in time, witnessing the state of that galaxy as it was when the light began its journey to us. When scientists talk about the cosmic horizon, they refer to the boundary beyond which we cannot observe due to the finite speed of light. Since the universe is expanding, this boundary is not static. As the universe grows, light from more distant regions continues to reach us, slowly unveiling parts of the cosmos that were previously hidden. The light we see from ancient celestial bodies reveals early conditions of the universe, offering clues about its formation and evolution. Additionally, light can tell us about the structure of the universe. Different wavelengths of light, like visible, infrared, or ultraviolet, provide various insights. For instance, observing in the infrared spectrum allows us to see cooler or dust-enshrouded objects that might be invisible to the naked eye. This diverse palette of light enables scientists to piece together a more complete picture of what lies beyond our observable universe. Moreover, light is affected by the universe's expansion. This effect is known as redshift, where light from distant galaxies stretches into longer wavelengths over time. Redshift measurements can help researchers estimate distances and speeds of galaxies, which furthers our understanding of how the universe is structured and its ultimate fate. Light is not merely a source of illumination, it is a crucial element in answering the profound questions about the universe's size, shape, and history. Through light, we gain a deeper comprehension of the cosmos that surrounds us, placing each discovery into the grand narrative of our universe's continuous expansion and evolution. The idea of the universe having an edge presents a complex challenge to how we perceive both space and time. Traditionally, we think of the universe as a vast, limitless expanse where one can travel endlessly in any direction. This picture becomes murky when we consider what an edge actually means. If the universe has a boundary, it prompts questions about what lies beyond that edge. Is there nothing, or is there something that we simply do not understand? This notion disrupts our understanding of space, as it raises the possibility that space may not be infinite. It challenges us to rethink the very nature of our existence within this cosmos. If the universe has an edge, it implies that our observations and experiences are confined to a particular area. This could mean that regions beyond our observable universe are unreachable, leading to the conclusion that there is more out there than we can ever perceive. Time is similarly affected by this concept. If the universe has an edge, it compels us to consider whether time behaves differently in those far reaches. It raises questions about whether time is uniform everywhere, or if it can be influenced by the structure of the universe itself. Observing distant celestial objects, we witness light that has taken billions of years to reach us, revealing a history of the universe that is finite in scope. If there is an edge, it could disrupt our understanding of the chronological flow of events and how we relate to the past, present, and future. As scientists study the universe's expansion, they suggest that it could be stretching beyond the limits of what we can see. This ongoing evolution keeps altering our perception, making us recognize that the universe might be far stranger than we can imagine. Ultimately, grappling with the concept of an edge compels us to confront the mystery of existence, our place within it, and the fundamental workings of time itself. The question of whether the universe has a boundary is fascinating and has captivated scientists and thinkers for centuries. One of the most popular theories is the idea of an ever-expanding universe. Imagine blowing up a balloon. As it gets larger, every point on its surface moves away from each other. In this analogy, the surface of the balloon represents our universe, and there isn't an edge per se, but rather, it keeps stretching, creating more space. Another significant theory is the possibility of a curved universe. Picture a sphere. If you were to travel along its surface, you would eventually return to where you started without ever encountering an edge. This suggests that our universe could also be curved in a higher dimension, implying it goes on forever in some sense without a definitive boundary. Additionally, there is the concept of a multiverse. This theory proposes that our universe is just one of many, each possibly having its own set of physical laws. If this is true, the boundaries of our own universe may exist only until they reach the edges of these other realms. In this way, the universe might not have a singular limit, but could be part of a larger, more complex structure. Moreover, some scientists explore the possibility of singularities at the universe's edge. A singularity is a point where the known laws of physics break down, like at the center of a black hole. This notion raises intriguing questions about what happens at the outermost limits of the universe and if there's anything beyond that boundary, if it exists. Finally, the cosmic microwave background radiation provides another clue. It's the afterglow of the Big Bang, visible everywhere in the universe today, suggesting that there was a beginning, but it doesn't necessarily indicate an edge. Rather, it encapsulates the moments when the universe began to cool and expand. These theories combine to paint a complex picture of the universe's boundaries, suggesting that our understanding is still evolving, and many mysteries await further exploration. Each perspective offers a unique lens through which we can view our universe's nature and existence. The Big Bang Theory explains the origins of our universe and how it has been expanding ever since its inception. Instead of thinking of the universe as having clear edges or boundaries, it's more accurate to visualize it as a balloon that is being inflated. When the balloon expands, every point on its surface moves away from each other. In this analogy, the surface of the balloon represents the fabric of space in our universe, while the points on it symbolize galaxies. As the universe continues to expand, space itself stretches, causing galaxies to drift apart from one another. Because space is expanding in all directions, there isn't a single edge or center to the universe. Every observer, no matter where they are, will feel as if they are at the center of this expansion. Moreover, if we consider the nature of the universe, it might not even end at an edge. Some theories suggest that the universe might curve back on itself, much like the surface of a sphere. In such a case, if you traveled far enough in one direction, you could eventually return to your starting point. Rather than an explicit limit, the universe is more accurately described as a three-dimensional space that is ever growing, ultimately challenging our traditional views of boundaries or edges. The idea of an expanding universe fundamentally changes how we think about the cosmos and its boundaries. Imagine blowing up a balloon. As the balloon expands, every point on its surface moves away from every other point. This is a helpful way to visualize our universe. The space between galaxies stretches over time, indicating that not only are galaxies moving apart, but the very fabric of space itself is expanding. Now, when we talk about an edge of the universe, things become a bit more intriguing. In our three-dimensional experience, we often think of edges as something definitive that separates what is inside from what is outside. However, in an expanding universe, there is no physical edge like that. Instead, space continues to stretch infinitely, meaning that if we travel far enough in any direction, we only see more galaxies receding from us due to this ongoing expansion. Moreover, this expansion implies that there are regions of the universe that are moving away from us faster than the speed of light, courtesy of the laws of physics. Because of this, light from those distant areas may never reach us, creating a sort of observable horizon rather than a sharp edge. Beyond this horizon lies a vast region that will remain inaccessible to our observation. Thus, when considering the expanding universe, we come to realize that while it may feel like a grand, boundless expanse, it lacks a clear boundary. This concept encourages us to think differently about space itself, highlighting how our universe may indeed be infinite, with no definitive start or end, just an endless journey through a continuously evolving cosmos. The multiverse theory proposes that our universe is just one of many, potentially infinite universes that exist simultaneously. Imagine a vast and intricate tapestry, where each thread represents a different universe, each with its own set of physical laws and constants. In this scenario, our universe is merely a single stitch in a complex arrangement, surrounded by countless others, each with distinct characteristics. Now, how does this relate to the edge of the universe? When we think about the edge of our universe, we're talking about the limits of what we can observe. The universe has been expanding since the moment it began, creating a boundary defined by the farthest point light has traveled since that beginning. Beyond this observable limit might lie other regions of space that continue to stretch endlessly. Some interpretations of the multiverse suggest that these other universes might exist in separate dimensions altogether, or even be separated by barriers we cannot detect. While the edge of our universe marks the limit of our knowledge and observation, the multiverse theory expands what we think possible, suggesting that beyond our reach, other realities could coexist, some radically different from our own. This idea challenges our understanding of existence and invites us to ponder the nature of reality on a cosmic scale, sparking curiosity about what lies beyond the familiar boundaries. String theory and the concept of parallel universes offer exciting and thought-provoking ideas that challenge and expand our understanding of the universe. String theory and the concept of parallel universes offer exciting and thought-provoking ideas that challenge and expand our understanding of the universe. Traditionally, we think of the universe as a vast, three-dimensional space filled with galaxies, stars, and planets. However, string theory suggests that there is much more beneath the surface of what we can observe. At its core, string theory proposes that the fundamental building blocks of everything are not tiny particles as we commonly believe, but tiny vibrating strings. These strings exist in multiple dimensions beyond the three we experience in daily life. You can imagine these strings as the strings of a musical instrument, where the way they vibrate determines the type of particle they represent. Because the universe may contain additional dimensions, potentially several more than we are aware of, this opens the door to entirely new physical laws and behaviors that could redefine our understanding of reality. Parallel universes, often linked to string theory, introduce the idea that there may be other universes existing alongside our own. In some scenarios, these universes could have different physical laws, dimensions, or even versions of ourselves making different choices. Imagine a vast cosmic garden where each universe grows like a separate plant, sometimes interacting, but often remaining unseen and isolated. This suggests that the limits of our universe aren't the final destination. Instead, they are just one of many possibilities. Combining these ideas, we can think of the universe as a complex tapestry woven with many threads, where each thread could represent a different universe shaped by distinct rules and properties. This layered understanding of reality not only challenges our perception of what the universe is, but also inspires scientists to explore questions that go beyond the observable. If different universes exist, each with their own unique characteristics, it could fundamentally transform our quest for knowledge and understanding in physics and beyond. Beyond the edge of the observable universe lies a realm that is largely a mystery. The observable universe is the portion of the universe we can see, limited by the distance light has traveled since the beginning of time. This means that we have a horizon that marks the furthest regions from which light has had the chance to reach us. But what exists beyond that horizon? Current physics suggests several intriguing possibilities. One idea is that the universe might be much larger than what we can observe. Beyond our observable limit, there may be countless galaxies, solar systems, and perhaps even life, all existing in a space that stretches infinitely. This implies that the universe doesn't simply end, but instead continues, potentially with varying structures and properties. Another fascinating concept is the multiverse theory, which posits that our universe could be just one of many universes, each with its own unique laws of physics. In this view, beyond our observable universe, there might be completely different realms, some where the rules of nature are very different from our own, leading to a diverse tapestry of cosmic possibilities. Moreover, it is also proposed that space itself may have properties we don't fully understand. For instance, there might be regions where space is expanding at different rates, or even areas that are entirely disconnected from us, where no light or information can ever reach our perspective. While we can only theorize and speculate about these realms, they show just how much we have yet to learn about the cosmos. The journey into the unknown continues, inviting us to discover what lies at the very boundaries of our understanding and beyond. Scientists face an intriguing challenge when it comes to observing beyond the observable universe, which is the part of space we can see because light from those regions has reached us since the beginning of time. To navigate this limitation, researchers rely on indirect methods and theoretical frameworks. Firstly, scientists use the cosmic microwave background radiation, which is like a faint glow left over from the early universe, to glean information about the universe's conditions shortly after its formation. This ancient light helps them understand the universe's structure, allowing them to make educated guesses about areas beyond our direct observational reach. Moreover, mathematical models and simulations play a vital role. These models help scientists predict how galaxies formed and evolved over time, extending their understanding beyond what can currently be observed. By understanding the physics of the universe, including the laws of gravity and the behavior of energy and matter, researchers can infer the properties of regions that lie beyond our observational limit. Additionally, scientists utilize advanced telescopes and instruments to look at the edge of the observable universe, striving to detect signals or remnants of ancient cosmic events. This pursuit includes studying distant galaxies, cosmic explosions, and other phenomena, allowing them to piece together a broader picture of the universe's structure. Even the nature of dark energy and dark matter, which make up much of the universe's mass and energy content, is explored through their effects on the observable universe. The unexplained gravitational effects hint at a cosmos filled with more mysteries, prompting scientists to ponder what lies beyond and pushing the boundaries of our understanding further than ever before. Through these methods, scientists not only navigate the limitations imposed by distance and time, but also continuously expand the horizon of our knowledge about the cosmos, promising to unveil more secrets of the universe in the future. The edge of the universe sparks imagination and wonder, as it represents the limit of what we can observe and understand. When we think about what might lie beyond this edge, several speculative ideas emerge, each more fascinating than the last. One possibility is the concept of infinite space. If the universe is infinite, then beyond what we see could simply be more universe, filled with galaxies, stars, and planets that stretch endlessly in every direction. In this scenario, the fabric of space continues indefinitely, untouched by the limits of our perception. Another intriguing idea suggests that there could be multiple universes, often referred to as a multiverse. This theory posits that what lies beyond our visible universe could be countless other universes, each with different laws of physics and distinct characteristics. Some of these universes may even contain variations of life or entirely different forms of existence. Some scientists speculate that there might be a boundary or edge to our universe, akin to a cosmic skin at the end of space. This boundary could house unique structures, exotic materials, or even darker regions where the laws of physics as we know them may change. An equally mind-bending thought is the idea that time and space may warp dramatically beyond our observable limits. This could lead to bizarre regions where concepts like time and distance do not function as we experience them, raising questions about how we define reality itself. Lastly, certain theories suggest that energy and matter do not just exist within our universe, but could spill over or collide with whatever lies beyond. This could impact the expansion of our universe and might provide clues that help us understand what exists in those unexplored realms. While these ideas are speculative, they invite curiosity and exploration. Each concept highlights just how little we know about the universe and the possibility that incredible truths lie hidden beyond the boundaries of our understanding. Black holes at the edge of the universe offer fascinating insights and significant challenges to our understanding of the cosmos. Imagine standing at the very boundaries of space, where the familiar laws of physics begin to blur and twist. These massive cosmic objects, formed from the remnants of collapsed stars, possess gravity so powerful that not even light can escape their pull. When we talk about black holes at the universe's edge, we're delving into areas where our knowledge becomes speculative and incomplete. One major challenge is the nature of space itself in these regions. Black holes could potentially influence the fabric of space-time, stretching and warping it in ways that challenge our conventional understanding. This can suggest that space does not behave consistently everywhere, particularly in the most remote corners of the universe. As scientists study these black holes, they are confronted with questions about what lies beyond them, creating theories that range from alternate histories of the universe to the possibility of other dimensions. Furthermore, black holes are not just dead ends. They hold information about the universe's formation and structure. They might reveal clues about the early universe's conditions or how galaxies form in their shadows. The mysteries surrounding them push researchers to reconsider existing theories of gravity, particularly in extreme environments. In contemplating what exists beyond these black holes, we grapple with concepts of universes or realms that could interact with ours, which could redefine our definitions of reality altogether. Essentially, these black holes challenge our imagination, urging us to think beyond the boundaries of current scientific understanding and explore the possibilities of infinite complexity within the universe. Each discovery about these enigmatic giants not only reshapes our cosmological theories, but also ignites a sense of wonder about what else lies out there, waiting to be unveiled. Wormholes represent fascinating theoretical tunnels in the fabric of space-time, and their connection to the universe's boundaries sparks intriguing ideas. To understand this, imagine the universe as a vast, expanding balloon. The surface of the balloon represents all the space we can observe. Now, if we think about a wormhole as a kind of shortcut, it's like pressing 2 points on the balloon together, creating a bridge between two seemingly distant areas of the surface. When we speak of the universe's boundary, we are often referring to the limits of what we can see or understand, areas where the known laws of physics might start to break down. In this context, wormholes suggest a way to traverse those boundaries. Theoretically, if a wormhole connects two different regions of space or even different times, it could enable light and matter to travel beyond what is visible from our perspective. But the universe's boundary isn't just a physical limit, it's also about concepts of time and gravity. At the edges of our universe, extreme conditions exist, and wormholes might offer a pathway to explore these realms without succumbing to the incredible forces that act there. They could serve as portals, allowing scientists to study regions we currently consider beyond our reach. Thus, exploring wormholes raises questions about the nature of boundaries themselves, hinting that the universe may not be as disconnected as we perceive it. It opens up the possibility that what lies beyond our visible horizon could be accessible through these mysterious cosmic shortcuts. Dark matter plays a crucial role in shaping our understanding of the universe, especially regarding its boundaries and structure. While we cannot see dark matter directly, we know it exists through its gravitational effects on visible matter. Imagine a vast cosmic web where galaxies are like beads strung along invisible strings. These strings are the gravitational influences of dark matter, which hold galaxies together and guide their movements. When we look at the universe, we find that galaxies are not evenly distributed. They tend to cluster in specific regions, leaving huge empty spaces in between. This clustering is largely due to dark matter creating a scaffolding that influences the formation of these structures. As we push our observations to the universe's edge, dark matter becomes pivotal. It helps us understand not only how galaxies form and evolve, but also how much mass is out there that we cannot detect. The edge of the universe, a concept often related to the observable universe, also hinges upon our understanding of dark matter. This invisible matter affects the overall expansion of the universe. Current models suggest that the universe is expanding at an accelerating rate because of a mysterious force also tied to dark matter. This expansion can redefine what we consider the universe's edge, as it pushes farther and farther away from us over time. Dark matter fills in the gaps of our cosmic knowledge. It is a key player in the structure of the universe and informs both the shape of galaxies and the very nature of space around us. As we continue to study it, our grasp of the universe's edges and its ultimate fate will become clearer, revealing the hidden forces that govern everything we see and don't see. The universe is constantly expanding, meaning that galaxies are moving away from each other over time. Dark energy plays a crucial role in this process. Imagine the universe as a balloon being blown up. As the balloon expands, everything on its surface moves away from one another. Dark energy is like the force behind the air filling the balloon, causing it to stretch more and more. In the early stages of the universe's expansion, gravity acted as the primary force, pulling matter together and slowing down the rate of expansion. Over time, scientists discovered that this expansion is actually accelerating instead of slowing down. That's when dark energy entered the picture. Dark energy is a mysterious substance that seems to permeate all of space. It does not clump like matter does, but rather provides a negative pressure that causes the universe to expand even faster. Think of it as pushing against gravity, making everything spread out more quickly. As a result, while galaxies still feel gravity's pull on one another, the overall effect of dark energy is to push them apart, influencing the universe at its grandest scale. This relationship between dark energy and the universe's expansion suggests that the universe is not just growing, but is doing so at an increasing rate, leading to fascinating questions about the future of the cosmos. If this acceleration continues, it could lead to a scenario where distant galaxies drift beyond our reach, becoming invisible to our observations. Understanding dark energy is thus vital for grasping the universe's fate and the ultimate boundaries of what we see and know. To understand how dark energy might impact what lies beyond the universe's edge, we first need to appreciate what dark energy actually is. Dark energy is a mysterious force that makes up a significant portion of the universe, and it plays a crucial role in its expansion. Picture the universe as a balloon being inflated. As it expands, galaxies move farther apart from each other, which is driven by dark energy. Now, when we talk about the edge of the universe, it's important to clarify that the universe does not have an edge in the sense of a physical boundary. Instead, it is constantly expanding, and as it does, dark energy drives this expansion at an increasing rate. This means that as we look deeper into space and time, some galaxies are moving away from us faster than the speed of light due to this relentless expansion. So what happens beyond this edge? Well, since the universe keeps expanding, dark energy might influence regions that seem to be beyond our observable universe. This could mean that there are areas we can never see or even reach as they continue to recede beyond our grasp. In a way, dark energy creates a dynamic landscape where portions of the universe slip out of view. Moreover, if dark energy continues to act the way it does, it could lead to a future where the universe stretches thin. In that scenario, most of the galaxies we see today may drift away until they become invisible, isolated by the vast expanses of space. This raises intriguing questions about the very nature of our universe and what lies in regions we cannot access. Essentially, dark energy not only shapes the current structure of the universe, but also raises mysteries about the future and the unobservable regions that extend endlessly beyond our sight. The exploration of dark matter and dark energy has dramatically transformed our understanding of the universe's structure and limits. To begin, dark matter is an invisible substance that does not emit light or energy, making it challenging to detect directly. However, scientists have inferred its existence through the gravitational effects it has on visible matter, like galaxies. This unseen mass helps bind galaxies together and explains why they spin at rates that would otherwise lead them to fly apart. Without dark matter, our understanding of how galaxies form and behave would fall apart. On the other hand, dark energy represents an even more mysterious force that accelerates the expansion of the universe. Initially, scientists thought the expansion of the universe might slow down due to gravity pulling everything inward. However, observations showed that not only is the universe expanding, but its expansion is actually speeding up. Dark energy, which makes up a significant portion of the universe, is theorized to drive this acceleration. These discoveries have prompted a new way of thinking about the universe's limits, challenging the notion of a static or infinitely expanding cosmos. Instead, the balance between the gravitational effects of dark matter and the repulsive nature of dark energy suggests that the universe might have a dynamic destiny. It raises questions of whether the universe will continue to expand indefinitely, slow down, or potentially even reverse and collapse in the far future. Dark matter and energy have reshaped our theories from a more simplistic, observable understanding of the cosmos to a complex, layered view filled with unseen forces. The universe is not just vast, it is filled with forces that challenge our comprehension, prompting scientists to rethink cosmic boundaries and the ultimate fate of everything that exists. Detecting dark matter beyond the observable universe presents significant challenges that stem from both our technology and our understanding of physics. To start, dark matter itself is elusive. It does not emit, absorb, or reflect light, which makes observing it directly through traditional astronomical methods nearly impossible. This lack of interaction with light means that dark matter cannot be seen with telescopes or other imaging tools. When we look beyond the observable universe, the greatest challenge arises from the sheer distance. The observable universe is defined by the farthest light we can see, taking into account how long that light has traveled since the beginning of time. Anything beyond this boundary is not accessible to us. This means that we cannot gather any direct evidence or observations of dark matter in regions that are beyond our current observational capacity. Furthermore, even if we could observe further, we still face the difficulty of distinguishing dark matter from other cosmic phenomena. Dark matter interacts with ordinary matter primarily through gravity, so we would have to rely on observing its gravitational effects on the motion of galaxies and galaxy clusters. However, distinguishing these effects from other gravitational influences can be complicated, especially at vast distances where the structures of the universe become intricate and less understood. Additionally, our current models of the universe are based on a limited understanding of cosmic evolution. If dark matter behaves differently in regions beyond the observable universe, it may not conform to the predictions of our existing theories. There is a possibility that we could miss vital clues about its nature and behavior simply because our established concepts might not apply outside familiar territory. Research continues as scientists seek alternative methods, such as using gravitational lensing, where the presence of dark matter bends the light from distant objects, and particle detectors designed to sense any possible interactions of dark matter. Yet, the vastness of space and the limitations of our technology mean that unraveling the mysteries of dark matter beyond the observable universe is a monumental challenge, demanding not only advancements in our observational tools, but also deeper insights into theoretical physics. Philosophical traditions have long pondered the nature of the universe and its boundaries, offering varied interpretations that reflect diverse worldviews. For some, the universe is seen as infinite, suggesting that it extends endlessly in all directions, much like space itself, which has no observable edges. This perspective aligns with certain Eastern philosophies, where concepts such as emptiness in Buddhism imply that boundaries are ultimately illusions, encouraging a view that transcends physical limitations. In contrast, Western philosophical thought often engages with the idea of the universe having defined limits. Ancient Greeks, like Aristotle, imagined a finite cosmos, with a clear structure that included celestial spheres encasing Earth. Such ideas suggested a universe that was ultimately knowable and categorized, leading toward a quest for understanding its laws. As thought evolved, so did interpretations. Enlightenment thinkers expanded upon the universe, often connecting it to mathematical reasoning, seeing boundaries less as physical barriers and more as concepts to explore. In this line of thinking, the vastness of space became a symbol of human curiosity and intellectual pursuit. Modern philosophy continues this exploration, sometimes merging with physics. Some scholars suggest that our understanding may reflect not just the universe's physical limits, but also our cognitive limits. This perspective raises profound questions about whether boundaries exist at all, or if they are constructs of human thought, shaped by cultural contexts and advances in knowledge. Ultimately, the philosophical inquiry into the universe's boundaries urges us to reflect not just on the nature of the cosmos, but on our place within it, the limits of our understanding, and the infinite possibilities that lie beyond our grasp. This ongoing dialogue shapes how we perceive reality and pushes the frontiers of what we might consider the universe itself. Contemplating the edge of the universe sparks profound existential questions that challenge our understanding of existence itself. To start with, one might wonder about the very nature of the universe. Does it have an ending? Or does it continue infinitely in all directions? This question prompts reflections about our place within this vast expanse. If we are located in just one corner of an infinite cosmos, what does that mean for our significance as individuals and as a species? Another layer of inquiry revolves around the concept of the universe's creation. How did everything we see come to exist? Are there limits to what we perceive, or could there be realms beyond our reach? This idea raises questions about life beyond Earth. If the universe is endlessly expansive, what possibilities exist for other forms of consciousness and civilization? Are we the only beings who ponder our existence, or are there others out there grappling with similar questions? Time also plays a crucial role in this contemplative journey. When we think about the universe's edge, we might consider not just how it was formed, but also how it could end. Understanding the beginning and potential demise of everything we know can evoke a sense of both vulnerability and wonder. Are we meant to seek knowledge about the universe's final fate, or is it something beyond human understanding? In contemplating these existential questions, we confront the limits of human knowledge and the mysteries that still remain. This journey into the unknown not only enriches our understanding of the cosmos, but challenges us to explore what it means to be alive in a universe that is as expansive as it is enigmatic. Ultimately, These questions remind us that in the grand narrative of existence, our curiosity and desire for knowledge are what connect us to the universe itself. The concept of the universe's edge has evolved dramatically over centuries, reflecting changes in our understanding of astronomy and physics. In ancient times, many cultures believed in a flat Earth surrounded by a dome-like sky. This worldview was influenced by direct observations where the horizon appeared like a boundary, suggesting a finite universe. As thinkers like Aristotle proposed a spherical Earth, the idea of a cosmic sphere emerged. The stars were thought to be fixed within this celestial dome. During the Renaissance, the groundbreaking work of astronomers like Copernicus and Galileo shifted our perspective. They presented the idea that Earth is not the center of the universe, but rather orbits around the sun. This heliocentric model opened the door to broader questions about the nature of the universe itself. With these new ideas came the realization that the universe might be much larger than previously thought. In the early 20th century, the discovery that the universe is expanding revolutionized our understanding. Edwin Hubble observed galaxies moving away from us, suggesting that the universe doesn't have an edge in the traditional sense. Instead of a bounded realm, what we consider the edge is merely the limit of what we can observe, known as the observable universe. Beyond this boundary could be more galaxies and cosmic structures, potentially extending infinitely. In modern cosmology, the notion of an absolute edge has been replaced by complex theories. Some models suggest that the universe could be curved, meaning if you travel far enough in one direction, you might eventually return to your starting point. Other theories propose the existence of multiple or parallel universes, further complicating the concept of an outer boundary. Thus, historical views on the universe's edge reflect humanity's relentless quest for knowledge. What began with simplistic images of a domed sky has transformed into profound questions about infinity and the very nature of existence. Each step in this intellectual journey reveals not just the physical world around us, but also the limitless horizons of human curiosity. Human curiosity is the driving force behind our exploration of the universe. It is what pushes us to ask profound questions about our existence and the cosmos. From the earliest days when we gazed up at the stars, wondering about the world beyond our own, curiosity sparked a desire to explore and understand. This quest leads to remarkable advancements in science and technology, enabling us to reach further into space than ever before. Curiosity motivates scientists to investigate the fundamental laws of nature. When we observe phenomena like black holes or the vastness of galaxies, this insatiable urge to know more becomes critical. It prompts researchers to develop new theories, conduct experiments, and design missions that seek to uncover the mysteries of the universe. Every discovery offers answers, but more importantly, it opens up new questions, expanding the boundaries of our knowledge. Moreover, this curiosity is not just limited to scientists. It resonates with people from all walks of life, inspiring artists, writers, and dreamers. The wonders of the cosmos have led to cultural and philosophical reflections that enhance our understanding of what it means to be human. This connection elevates the quest beyond mere scientific endeavor. It becomes a shared human experience that binds us together in seeking the infinite. As we delve into the limits of the universe, curiosity leads us to confront the unknown, whether that involves the nature of dark matter, the potential for other life forms, or the ultimate fate of the cosmos. Each exploration represents a step toward unlocking these mysteries, demonstrating that our quest is not merely about understanding the universe, but also about understanding ourselves within it. Through curiosity, we bridge the gap between imagination and reality, reshaping our role in the grand tapestry of existence. The concept of the universe's edge challenges our understanding of boundaries and infinity. Contrary to a simple idea of an outer limit, the universe's edge can be thought of as a horizon that is always shifting. Imagine standing at the beach. As you look out to sea, you can see only so far before the water seems to meet the sky. Yet, you know that the ocean continues far beyond what you can see. In the same way, the universe seems vast, but it may be much larger or even unending. This idea encourages us to rethink our perception of what lies beyond our current knowledge. Just like ancient explorers believed the world ended at the horizon, we too may perceive the universe as having a definite limit based on what we can observe. However, with advancements in science, we discover that our view is restricted by technology and perspective, not by the universe itself. Understanding the universe's edge also mirrors our quest for knowledge. As we strive to uncover the mysteries of the cosmos, we often find that each answer reveals even more questions. This endless pursuit reflects the nature of human curiosity. Our perception shapes our exploration, reinforcing the idea that our quest for understanding is as limitless as the universe itself. Each breakthrough inspires us to look beyond what we think we know, revealing a vast expanse of possibilities and ideas that challenge our imaginations and intellect. Contemplating the universe's edge reveals not just the limits of the cosmos, but the boundless capacity of human thought and exploration. Advancements in telescope technology have revolutionized our understanding of the universe's edge in remarkable ways. In the past, astronomers relied on simple optical telescopes which gathered limited light and provided only a glimpse of the cosmos. Today's advanced telescopes, including both ground-based and space-based instruments, have significantly enhanced our ability to observe distant galaxies and cosmic phenomena. One of the biggest breakthroughs has been the introduction of larger mirrors and improved lens designs. These modern telescopes can collect more light, allowing us to see fainter objects that were once invisible. This means we can explore deeper into space and detect ancient galaxies that formed shortly after the Big Bang. Observations of these distant objects help us understand how the universe evolved over billions of years. Additionally, technologies like infrared and radio wave detection allow us to observe celestial bodies that emit light not visible to the human eye. This has unveiled previously hidden aspects of the universe, such as the formation of stars within dust clouds or the presence of dark matter in the structures of galaxies. These observations have also provided critical evidence for theories about cosmic expansion and the overall shape of the universe. The development of adaptive optics has further refined our observations by compensating for turbulence in the Earth's atmosphere, producing clearer images from ground-based telescopes. Moreover, space telescopes like the Hubble Space Telescope have no atmospheric interference, offering stunning clarity and detail in the images they capture. Together, these advancements contribute to a continually evolving understanding of the universe's edge, revealing not just what exists beyond our sight, but also deepening our comprehension of its history, structure, and future. Each discovery pushes the boundaries of what we know and sparks new questions about our place in this vast cosmos. Space missions are crucial for pushing the boundaries of our understanding of the universe. They act as our eyes and ears in the cosmos, allowing us to gather data that we can't obtain from Earth. These missions can literally travel millions or even billions of miles, reaching parts of space that are otherwise inaccessible. When a spacecraft is launched, it carries powerful instruments designed to observe celestial bodies, collect samples, and measure various cosmic phenomena. By studying distant planets, asteroids, and comets, we learn not just about their individual characteristics, but also about the history and evolution of our own solar system. Moreover, missions that venture beyond our solar system, such as those aimed at exploring the outer planets and even interstellar space, give us insights into the mysterious forces that govern the universe. They help scientists investigate fundamental questions about dark matter, black holes, and the potential for life on other worlds. In many cases, space missions have provided groundbreaking discoveries that reshape our view of the universe. For instance, missions like the Hubble Space Telescope have uncovered previously unseen galaxies and allowed us to measure the expansion of the universe itself. The data gathered can also help to refine our existing theories, showing us when adjustments need to be made to our scientific understanding. In addition to their scientific importance, space missions inspire us. They captivate the imagination and encourage a new generation of scientists, engineers, and explorers. By venturing into the unknown, they remind us that the universe is not just a backdrop, it's a vast expanse of resources for discovery. Each mission not only expands our knowledge, but also rekindles our curiosity about what lies beyond the stars. Upcoming technologies are poised to revolutionize our understanding of the universe's farthest reaches. One significant advancement is in telescope design, particularly through the development of larger and more sensitive instruments. These telescopes will be able to capture more light from distant galaxies, allowing scientists to observe objects that are billions of light years away. Imagine looking deeper into space than ever before and uncovering new celestial bodies that have remained hidden from our current view. Another area of progress lies in space exploration technologies. New spacecraft will be equipped with advanced instruments capable of gathering data from regions that were previously unreachable. These crafts will be designed to propel themselves beyond the traditional boundaries of our solar system, exploring the cosmic landscape in greater detail. As they traverse vast distances, they can collect invaluable information about the origins of the universe and the formation of galaxies. Artificial intelligence is also playing a critical role in analyzing the data collected from these instruments. With AI, researchers can process enormous amounts of data faster and more accurately than before. This technology can identify patterns and anomalies that might be missed by the human eye, leading to groundbreaking discoveries about the universe's structure and evolution. Moreover, collaboration among international space agencies is becoming more common, pooling resources and knowledge. Joint missions can tackle ambitious projects like sending probes to distant celestial phenomena or analyzing light from the universe's first stars. Together, these advancements in technology, exploration, and collaboration create a promising future for studying the universe's edges and uncovering mysteries that have long eluded us. The coming years hold the potential for profound discoveries that could reshape our understanding of existence itself. Quantum computing holds the promise of revolutionizing our understanding of the universe, particularly at its edge, where traditional methods struggle. Think of the current computers like classic tools trying to solve a massive jigsaw puzzle, with many pieces scattered across a vast table. They can work through the pieces one at a time, but they take a long time to finish. In contrast, quantum computers are like a clever team of tiny helpers that can look at multiple pieces all at once, dramatically speeding up the process. As we explore the edge of the universe, scientists face incredibly complex problems. These include understanding the nature of dark matter, an invisible substance that makes up a significant portion of the universe, or the behavior of particles in extreme conditions. Quantum computing can analyze vast quantities of data and simulate intricate systems far more efficiently than classical computers. This ability could help us develop models that better explain phenomena that have long puzzled scientists. Additionally, quantum computers can handle uncertainty in ways that traditional computers struggle with. This is crucial, as much of our understanding at the universe's edge involves probabilities rather than certainties. By leveraging quantum states, these advanced machines can help improve predictions and reveal deeper insights into cosmic events like black holes and the expansion of space. Imagine being able to crunch numbers and solve equations on a scale previously thought impossible. With these powerful tools, researchers could delve deeper into the mysteries of the cosmos, piecing together the tapestry of the universe's edge, perhaps even guiding us toward explanations for fundamental questions about existence itself. As quantum computing evolves, it could lead to breakthroughs that bring the farthest reaches of the universe into clearer view, making the seemingly unreachable both attainable and comprehensible. In recent years, astronomers have made significant discoveries that challenge our understanding of the observable universe. One of the most surprising findings comes from studying galaxies that existed when the universe was very young, only a fraction of its current age. Research shows that some of these galaxies are forming stars at an astonishing rate, far exceeding what was previously thought possible. This suggests that galaxies may mature and evolve much faster than the existing models predicted. Another breakthrough stems from advanced telescopes, such as those designed to capture images in different wavelengths, including infrared light. These telescopes have uncovered distant cosmic objects, such as galaxies and quasars, that existed when the universe was only a small fraction of its age. This discovery pushes the boundaries of our observable universe, revealing that there may be many more galaxies waiting to be discovered that challenge our notions of what the early universe looked like. Moreover, the detection of gravitational waves has opened a new window to observe the universe, allowing scientists to gain insights into cosmic events that could not be seen with traditional telescopes. These waves provide information about massive cosmic events, like the collision of black holes or neutron stars, which helps us understand the evolution of the universe further back in time than ever before. Together, these findings suggest that our universe is likely larger and more complex than we previously imagined, prompting scientists to rethink some fundamental theories in cosmology. With each discovery, we are not just peering further into space, but also expanding our understanding of how the universe has changed over time and how it continues to evolve. The quest for knowledge about the cosmos is ongoing, and as technology advances, we are likely to find even more ways to explore and understand the vast universe surrounding us. As humanity moves closer to understanding the universe's edge, we are likely to encounter profound mysteries that could redefine our place in the cosmos. First and foremost, the nature of the universe's expansion raises questions. Observations show that galaxies are drifting apart at an accelerating rate, suggesting a force we still do not fully comprehend. This mysterious force, often referred to as dark energy, makes up a significant part of the universe, yet its exact properties remain elusive. Exploring the edge of the universe might also lead us to uncover the true fabric of space and time. Currently, scientists theorize that space is not just an empty void, but has a complex structure that could be influenced by hidden dimensions or different dimensions of reality. If we could gather more data from the edges of the observable universe, we might start to understand these dimensions and their relationship to the universe's formation. Additionally, there could be insights into the existence of other forms of life. The idea of extraterrestrial civilizations grows more tantalizing as we find exoplanets and study their atmospheres. If we reach areas of space where conditions vary greatly, we may discover environments that could harbor life forms unlike anything we know, further expanding our concept of life. The edge of the universe may also reveal the history of cosmic events that shaped our existence. Observations of ancient light, dating back to the beginning of time, can provide glimpses into the origins of galaxies, stars, and planets. This knowledge may lead to a better understanding of how the elements that make up our own world were forged in the hearts of stars, and what the future might hold for our own planet in the vast, ongoing story of the universe. As we explore what lies beyond our current reach, we open doors to a better grasp of dark energy, the structure of space, potential life beyond our planet, and the history of cosmic creation. The mysteries at the universe's edge promise to reshape our understanding and challenge what it means to be human in the grand scope of the cosmos. The search for extraterrestrial life often leads scientists to consider the vastness of the universe, including its edge or boundary. To understand this connection, we first need to think about the universe as a vast expanse filled with countless stars, planets, and potential habitats for life. Some researchers believe that life beyond Earth might exist on distant exoplanets, which are planets outside our solar system, many of which orbit stars in regions far from us. When we talk about the edge of the universe, we're referring to the limits of what we can observe. The universe is expanding, pushing galaxies away from each other, which creates a horizon beyond which we cannot see. This boundary is not a physical edge, rather, it is a limit imposed by the speed of light and the age of the universe. Beyond this observable region, there could be vast areas that hold planets capable of supporting life, but we have no means to directly study them at the moment. The search for extraterrestrial life often focuses on finding planets in habitable zones around stars, where conditions might allow for liquid water and, subsequently, life as we know it. As we examine regions closer to the edge of our visible universe, astronomers hope to discover galaxies and planetary systems that differ from our own, expanding the possibilities for where life might exist. Moreover, studying the universe's edge can reveal insights into its origin and evolution. As we learn more about the universe's early stages and its ongoing expansion, we may uncover hints of environments that fostered life long ago. This exploration ties back to our curiosity about whether we are alone in the cosmos. The quest for extraterrestrial life is not limited to our immediate cosmic neighborhood. By investigating the edge of the universe, scientists aim to glimpse possibilities far beyond our reach, fostering a deeper understanding of life's potential in the ever-expanding fabric of space. At the edge of the universe, or what we consider its boundary, the phenomena observed could challenge our understanding of physics. Imagine standing at the edge of a vast expanse where the light from countless stars and galaxies has traveled for billions of years to reach us. Here you might encounter unexpected bursts of energy, like cosmic rays, which are high-energy particles shooting through space at incredible speeds. These particles can come from distant supernovae, or even mysterious objects we have yet to fully understand. You might also notice a curious phenomenon known as the cosmic microwave background radiation. This faint glow is the remnant heat from the Big Bang and gives us a window into the universe's early moments. Interestingly, far from being uniform, this radiation shows tiny fluctuations which hint at the seeds of all structures like galaxies and clusters that formed over time. At the universe's boundary, the expansion of space itself can create unusual effects. Galaxies and clusters are moving away from us, some so quickly that light from them can barely reach us. This results in a phenomenon called redshift, where the light stretches and shifts toward longer wavelengths, changing from blue tones to red. Observing this can lead to speculations about the universe's fate, whether it will continue to expand forever, slow down, or eventually collapse. Each discovery invites new questions, ultimately expanding the horizon of what we know about the cosmos. Discovering a new form of matter has the potential to reshape our understanding of the universe in profound ways. Currently, we categorize matter into substances like solids, liquids, and gases. Most of what we know is based on familiar forms of matter, along with exotic forms, such as plasma. However, theorizing about new matter can open doors to concepts previously limited to science fiction. Imagine a form of matter that has unique properties, perhaps allowing for stability at extreme conditions or exhibiting forms of interaction we have yet to see in nature. This discovery could challenge long-standing theories about how matter behaves in different environments, such as in the incredibly cold depths of space or around the intense gravitational pulls of black holes. When we think about the universe's edge, we picture boundaries that define what we can observe and understand. A new matter form might offer insights into mysterious phenomena, like dark matter and dark energy, which together make up most of the universe's total mass and energy, yet remain elusive. If this new matter could interact differently with gravity or electromagnetism, it might explain why galaxies behave the way they do, or why the universe's expansion is accelerating. Furthermore, this deeper knowledge could lead to revolutionary technologies or methods for exploring space. We might find new ways to create energy, travel vast distances, or even understand the fabric of the universe, redefining our place within it. Ultimately, discovering a new form of matter could illuminate mysteries at the universe's edge that puzzle scientists today, potentially revealing that our reality is far richer and more complex than we ever imagined. Exploring the universe's edge could lead to discoveries that drastically affect our everyday lives in ways we might not yet imagine. When scientists study distant galaxies, cosmic radiation, and dark matter, they aren't just looking at the stars. They are uncovering fundamental truths about the universe. These truths can inspire new technologies and scientific advancements. For instance, understanding how stars form and die influences materials science. Innovations in star energy can lead to breakthroughs in solar power, enabling more efficient solar panels that could power our homes with renewable energy. Additionally, studies of extreme environments in space, like those around black holes or neutron stars, can lead to advancements in materials that can withstand extreme conditions on Earth, such as stronger and lighter materials for buildings, vehicles, or even everyday electronics. Another significant area is communication. Researching cosmic phenomena can enhance the way we understand data transmission. The technology used to study pulsars or gravitational waves could inspire improvements in our communication networks, making them faster and more reliable. Furthermore, the exploration of extraterrestrial worlds might encourage advancements in life support systems and sustainability technologies that could be applied back home. As we learn how to survive in harsh environments beyond our planet, these techniques can be adapted to improve our resource management, water purification methods, and waste recycling processes on Earth. Lastly, discovering new planets or even signs of life could shift our perspective on humanity's place in the universe, fostering a greater sense of unity. This sense of community could inspire actions toward global challenges, such as climate change, as we share the responsibility for our planet's well-being. In short, the mysteries at the universe's edge hold the potential not just for scientific knowledge, but for practical advancements that could enhance our quality of life here on Earth. Each discovery opens new doors that may transform how we live, work, and understand our surroundings. Imagine the universe as a vast ocean, stretching endlessly in every direction. Now think of the boundary that surrounds this ocean as something entirely different, a realm filled with possibilities we can only hypothesize about. Beyond the observable universe, some scientists suggest that there might be regions with completely different physical laws, creating conditions unlike anything we experience here. One possibility is the existence of other universes, often referred to as the multiverse. In this scenario, each universe could have its own set of rules, leading to various outcomes like different forces or particles, or even structures that don't form in our universe. This means in one universe, gravity may be stronger or weaker, potentially influencing how stars and galaxies develop. Another intriguing idea is that beyond our universe, there may be an area filled with chaotic energy, a space where time behaves differently or could even be irrelevant. This might resemble a highly unstable void where new universes are born through fluctuations, like bubbles forming in boiling water, constantly expanding and popping into new realities. Additionally, some theories propose that the boundary itself could undergo changes over time, creating new forms of matter or energy that we cannot yet comprehend. If these conditions exist, they might be utterly alien to our understanding and lead to remarkable discoveries unfolding in ways we've never imagined. Exploring what lies beyond our universe pushes the limits of our imagination and challenges the very foundation of what we know about existence. While these concepts remain speculative, they open a window into the mysteries of the cosmos and what unseen possibilities might await us just beyond the edges of our knowledge. The idea of space-time combines the three dimensions of space with the dimension of time into a single framework. Think of space-time as a fabric that stretches, bends, and warps. This view is essential when we consider the universe's structure, especially regarding its edges or boundaries. According to established theories, the universe is not just a vast collection of stars and galaxies, but also a dynamic entity that is expanding. This expansion creates a relationship between space and time. When we talk about the universe's edge, we might think of it like the surface of a balloon. As the balloon inflates, the surface stretches, and points that were close together move farther apart. This means that the edge of the universe isn't a fixed boundary, but rather a moving frontier, influenced by the space-time fabric surrounding it. The concept of space-time helps scientists understand how gravity pulls on objects, like planets and stars, while also shaping the overall geometry of the universe. Just as massive objects cause dips in the fabric of space-time, the universe's expansion influences how distant galaxies move away from us. This connection provides insights into the universe's fate. It can tell us whether it will keep expanding forever, slow down, or even eventually collapse. Space-time isn't just a backdrop. It's an active participant that shapes our understanding of the universe. By exploring how space-time interacts with the universe's growth and edges, we gain deeper insights into its origins, structure, and ultimate destiny. The interplay between space and time reveals not only where boundaries might be found, but also the mysteries that lie beyond them. At the edge of the universe lies a realm that inspires both awe and curiosity, leading to several imaginative theories about what might be found there. One of the most captivating ideas is that the universe could be curved, meaning it doesn't have a definitive edge in the traditional sense. Instead, if you were to travel far enough in one direction, you might find yourself returning to your starting point, much like walking around a sphere. This concept suggests that there is no outside boundary, challenging our typical understanding of space. Another theory posits the existence of a multiverse. This suggests that our universe is only one of many, each potentially having different laws of physics, dimensions, and even outcomes of cosmic events. If true, the edge of our universe could lead to other realities, each with its own unique characteristics and possibilities. This idea hints at an infinite array of universes that exist parallel to ours, where everything we know could have myriad variations. There's also the concept of cosmic inflation. This theory proposes that in the early moments after the Big Bang, our universe underwent rapid expansion. If the universe continues to expand, the edge might represent areas where new regions of space are forming continuously. So the edge may not be a boundary, but rather a dynamic frontier where new matter and energy are being created. Finally, some scientists theorize about the voids, massive regions of space that appear empty. These expansive areas could be the remnants of ancient energy fluctuations that shaped the cosmos. Exploring these voids might lead to new insights about the structure and evolution of the universe itself. These theories evoke a sense of wonder, showcasing the complexity and depth of our universe. As scientists continue to study and explore the unknown, our understanding of what lies at the edge is sure to evolve, revealing more about the intricate tapestry of existence itself. Quantum entanglement presents a fascinating challenge to our understanding of how the universe is structured. At its core, entanglement describes a phenomenon where pairs of particles become interconnected in such a way that the state of one particle instantly influences the state of the other, no matter how far apart they are. Imagine two dancers moving in perfect harmony with each other, even when separated by great distances. This instantaneous connection seems to defy the limits imposed by the speed of light, which is a fundamental rule of our universe. Consequently, if entangled particles can communicate across vast stretches of space in an instant, it leads us to rethink what we consider the boundary of our universe. Rather than viewing space as a strict separator between distant objects, we might consider it more like a web where connection exists, even when we can't see it. This idea suggests that the universe could be more interconnected than we think, with boundaries that are not physical walls, but rather limits imposed by our understanding and perception. Furthermore, entanglement raises intriguing questions about the nature of information in the universe. If information can be shared faster than light through entanglement, it challenges the very fabric of causality, the principle that cause precedes effect. As we delve deeper into this realm of quantum mechanics, we might discover that the universe is not just a place of separate entities, but rather a vast, interconnected system that defies our conventional boundaries. This realization could lead to profound shifts in our understanding of reality itself, propelling us into a new era of scientific exploration where the boundaries of the known universe expand endlessly. Abstract mathematical models serve as powerful tools for understanding the universe and its boundaries. Picture these models as intricate blueprints, constructed from mathematical concepts that help scientists visualize complex ideas about space, time, and gravity. They provide a framework to translate observations into a language we can analyze. When investigating the universe's edge, or the regions far beyond what we can directly observe, these models allow researchers to formulate hypotheses about what exists there. For instance, they can describe how galaxies evolve, how dark matter interacts, and how cosmic structures form over time. By using equations and abstract concepts, scientists can simulate various scenarios, testing how different variables might affect the universe's expansion or the behavior of energy in extreme conditions. As we explore these mathematical landscapes, models can also shed light on fundamental questions like the nature of cosmic inflation, a process believed to have occurred just after the Big Bang. By utilizing these concepts, scientists can predict how the universe might behave under different conditions, effectively extending our understanding into realms that remain mysterious. Ultimately, while we may not be able to visually explore every corner of the universe, these abstract models bridge the gap between what we can observe and what lies beyond, guiding our quest for knowledge and expanding our grasp of reality. At the edge of the universe, we encounter phenomena that challenge our understanding of space and time. Imagine being in an area where the fabric of the universe stretches thin, much like the edge of a vast ocean where land meets water. This region is not just a boundary, it's a dynamic frontier filled with intriguing possibilities. One of the most captivating phenomena is the potential presence of cosmic voids. These vast, empty spaces are like bubbles in the universe, where very few galaxies exist. As you move towards these voids, the gravitational influence becomes different, allowing us to better understand how matter is distributed throughout the cosmos. Additionally, we might witness the effects of cosmic expansion. The universe is continually stretching, and at the fringes, this expansion can appear to accelerate. This means that some faraway galaxies are moving away from us faster than those closer by, influenced by mysterious forces that scientists refer to as dark energy. This enigmatic force drives the accelerated expansion of the universe, hinting that the edge isn't just a simple boundary, but a complex area of dynamic change. Gravitational waves might also be more prevalent near the extreme edges, created by massive cosmic events such as colliding black holes or merging neutron stars. These ripples in space-time can travel vast distances, providing us with information about the most violent and energetic processes in the universe. Lastly, the edge of the observable universe acts as a gateway to mysteries beyond what we can currently see or understand. Here, theories about the multiverse arise, suggesting that our universe might be one of many, potentially bursting with different laws of physics. At this boundary, imagination meets the unknown, opening doors to new scientific theories and explorations. The edge of the universe is a bustling area of cosmic wonders, where quiet voids, expanding galaxies, rippling waves, and abstract possibilities intertwine, offering a fascinating glimpse into the nature of existence itself. Cosmic strings are fascinating theoretical constructs that emerge from the physics of the early universe. To visualize them, think of them like long, thin threads extending across vast distances of space. They are believed to be remnants from the moments just after the Big Bang, when the universe underwent rapid changes and cooling. In the context of the universe's boundaries, cosmic strings may suggest that our universe is not simply infinite, but could have edge-like properties. When we talk about boundaries, we don't mean a solid wall, but rather a point where the familiar rules of physics might change. Cosmic strings could represent regions of space where matter and energy interact in unique ways, possibly influencing the structure of the universe on a grand scale. The presence of these strings might help shape galaxies or even clump matter together, acting almost like gravitational scaffolding. Thus, they could provide clues about the universe's overall architecture and its potential limits. The study of cosmic strings opens up discussions about the very fabric of the universe, prompting theories that question how space and time are woven together. Moreover, if cosmic strings exist, they could help explain certain features of the cosmic microwave background, the faint glow left over from the Big Bang. Observations of this background radiation might reveal patterns that point to the influence of these strings. In this way, studying cosmic strings not only furthers our understanding of theoretical boundaries, but also connects to observable phenomena, leading to a richer picture of our universe and its origins. The edge of the universe, often referred to as the observable universe, is where our current technology limits our ability to see further into space. When scientists investigate this boundary, they often encounter intriguing anomalies that challenge our understanding of the cosmos. One notable anomaly is the existence of large-scale structures, like enormous voids and galaxy clusters. These vast gaps in space can stretch for millions of light-years, containing significantly fewer galaxies than other regions. This uniformity and size suggests that the universe may have evolved in ways we do not fully comprehend. Another intriguing observation involves cosmic microwave background radiation, which is the afterglow from the Big Bang. It shows slight irregularities that appear to have a peculiar alignment and large fluctuations in temperature. This inconsistent pattern raises questions about the symmetry of the early universe and what might have influenced its formation. There's also the mysterious dark energy that seems to be causing the accelerated expansion of the universe. Its effects become more pronounced when we look at distant galaxies at the edge. This energy remains elusive, making up a significant portion of the universe while defying our understanding. Lastly, some researchers have detected potential signals or patterns that could hint at the presence of other dimensions or universes, leading to fascinating theories about a multiverse. Each of these anomalies offers a glimpse into a broader mystery, suggesting that what lies beyond our observational horizon may hold answers that could reshape our knowledge of the universe itself. Gamma-ray bursts are among the most powerful and energetic explosions observed in the universe, and they are thought to occur in distant galaxies when massive stars collapse or when neutron stars collide. Their immense brightness can outshine entire galaxies for a brief moment and carry tremendous amounts of energy across great distances. This provides astronomers with valuable insights into the structure and evolution of the cosmos. When scientists study these bursts, they consider their timing and locations in relation to cosmic events, which can influence theories about the universe's boundaries. For example, the detection of gamma-ray bursts in various regions of the universe indicates that star formation is happening continuously, even in the farthest reaches. This suggests that the universe is dynamic and constantly evolving, opposing ideas of a static, unchanging cosmos. Moreover, Analyzing the light from these bursts allows researchers to understand the expansion of the universe. As the light travels across billions of years to reach us, it stretches due to the universe's expansion, providing clues about its rate of growth. This information can challenge or refine existing models of the universe's structure, including its boundaries. On a larger scale, gamma-ray bursts might also influence theories related to the universe's ultimate fate. If these events are a sign of extreme energy and matter interactions, they could hint at how regions of the universe might behave at its outer limits. Thus, the study of gamma-ray bursts not only enhances our understanding of extreme cosmic phenomena, but also plays a crucial role in shaping our ideas about the universe's formation, expansion, and boundaries. Supernovae, the spectacular explosions of massive stars, serve as cosmic beacons illuminating our understanding of the universe's boundaries. When a star exhausts its nuclear fuel, it can no longer support its mass, leading to a dramatic collapse and subsequent explosion. This event releases an enormous amount of energy and shines brighter than entire galaxies for a brief period. These explosive phenomena are not just visually captivating, they play a critical role in measuring cosmic distances. Certain types of supernovae, particularly those known as type Ia supernovae, occur when a white dwarf, a remnant of a star, accumulates matter from a companion star until it reaches a critical limit. At this point, it undergoes a runaway nuclear fusion reaction, resulting in a consistent brightness at peak explosion. Astronomers use this predictable luminosity as a standard candle, a reliable reference point for gauging distances across vast cosmic landscapes. By measuring how dim these supernovae appear from Earth, scientists can infer how far away they are. Moreover, the study of supernovae has profound implications for understanding the universe's expansion. In the late 20th century, observations of distant type Ia supernovae revealed that the universe is not just expanding, but that this expansion is accelerating. This unexpected discovery led to the concept of dark energy, a mysterious force driving this acceleration. Supernovae thus provide crucial data, helping scientists to explore questions about the underlying forces shaping our universe, its age, and its ultimate fate. Supernovae are vital to cosmic research, serving both as markers for measuring distances and as catalysts for understanding the dynamics of the universe. Their intense energy and consistent properties enable astronomers to probe deep into the cosmos, pushing the boundaries of what we know. Exploring the edge of the universe poses significant challenges, both in technology and understanding. First, consider the sheer distance involved. The universe is vast, and the closest galaxies are trillions of miles away. Traveling such distances with our current technology would take unimaginably long periods of time, far beyond a human lifetime. This means that any mission would require spacecraft capable of sustained life support or advanced automation, which we are still developing. Moreover, as we venture further out, the conditions become harsher. Space is a hostile environment filled with radiation, extreme temperatures, and micrometeorite impacts. Designing equipment that can protect instruments and humans over such long journeys is a major hurdle. We also face the challenge of communication. The farther we go, the longer it takes for signals to travel back and forth. This delay complicates real-time decision-making and requires a high degree of independence for any exploratory missions. Understanding the physics of the universe's edge also presents challenges. As we reach the limits of what we can see and measure, we encounter phenomena that defy our current understanding of physics. For example, concepts like dark energy and the nature of the universe's expansion still puzzle scientists. The extreme conditions near the boundaries may also reveal new physics that we have yet to comprehend. Finally, there are philosophical and ethical considerations. As we push toward the boundaries of the known universe, we must reflect on our motivations for exploration. Are we prepared to face the implications of what we might find? Understanding our place in such a vast cosmos adds depth to the challenges of exploration. The journey to the universe's edge encompasses immense distances, hostile environments, communication complexities, scientific mysteries, and profound ethical questions. Each of these areas presents unique difficulties that require innovative thinking and advanced technology, challenging our current boundaries of exploration. Digital simulations are becoming essential tools for exploring the outer boundaries of the universe. Imagine trying to understand a vast and complex landscape that is constantly changing and often remains unseen. Real-world observations can be incredibly challenging due to the immense distances and the limitations of our instruments. This is where simulations step in, acting as a virtual playground for scientists to model and predict cosmic phenomena. By using computer-generated models, researchers can replicate various scenarios of cosmic evolution. These simulations allow them to test theories about the formation of galaxies, the behavior of dark matter, and even the expansion of the universe itself. Scientists can tweak variables within these simulations to see how different conditions might affect the universe's development. For example, they can simulate what happens when matter gathers to form stars, or how galaxies collide and merge over millions of years. Moreover, simulations help bridge the gap between theoretical physics and observable data. When astronomers spot unusual signals or celestial events, they can run simulations to understand what might have caused them or predict how they will evolve. This connection between simulation and observation helps scientists refine their models, enhancing our understanding of the universe step by step. As we push the limits of technology, simulations will incorporate more data, becoming increasingly detailed and realistic. Virtual exploration can lead to new insights that guide future observations, perhaps even leading us to areas of the universe we have yet to explore physically. Digital simulations help us navigate the cosmos, illuminating the mysteries that lie at its farthest edges. Exploring the edge of the universe is a captivating thought, but it presents challenges that stretch our imagination and technology. The edge of the universe refers to the observable limits of our cosmic neighborhood, which is not a physical boundary, but instead a horizon defined by the farthest light we can currently see. This light comes from the dawn of time, when the universe was still young. Traveling to that boundary is not as simple as jumping into a spaceship and heading in a straight line. First, consider the vastness of space. The universe is not only incredibly large, but also constantly expanding. This means that even if we sent a probe toward the edge, it would not simply reach a destination. Instead, the places we aim for keep moving away from us due to this expansion. As a consequence, our journeys could feel like running after a mirage, where the goal continuously shifts further out of reach. To even think about reaching the edge, we must think about our current technology. The fastest spacecraft we've built would take thousands of years to reach only a fraction of the way to our closest neighboring stars. To venture toward the edge of the observable universe would take us far beyond that. We would need innovative propulsion systems, perhaps something relying on concepts like harnessing energy from stars or using theoretical constructs such as warp drives that could bend space itself. There is also the fundamental question of what we might find at the universe's edge. As we look deeper into the cosmos, we see galaxies forming, stars igniting, and the remnants of colossal collisions. Each observation brings new wonders and deepens our understanding of cosmic history. However, as we move toward the edge, we encounter the possibility of regions where the light from galaxies has not yet reached us, areas filled with darkness and mystery. Imagine if we could create technology that allows us to jump through time and space, or send human-like robotic explorers into these distant realms. Such advancements could lead to breathtaking discoveries, perhaps finding signs of other civilizations, extraordinary phenomena, or cosmic events previously untouched by human curiosity. Ultimately, the quest to explore the universe's edge is a blend of science, ambition, and human spirit. With every step we take in space exploration, we broaden our horizons, not just of where we go, but of our very understanding of existence. This endless pursuit fuels endless questions and highlights the marvels waiting in the dark void beyond our reach. Future space policies will play a vital role in shaping how we explore the boundaries of our universe. As nations and private organizations venture into space, clear and thoughtful regulations can help guide these efforts. Effective policies can foster international collaboration, which is crucial for sharing knowledge and resources. When different countries cooperate, they can pool their technologies, making it easier and more efficient to tackle the complex challenges of space exploration. Furthermore, strong commitments to peaceful exploration can ensure that all nations respect one another's rights in space. This cooperation is essential when scientists aim for ambitious projects, such as sending missions to the edge of our solar system or even engaging in interstellar research. Policies that encourage sustainable practices will also be important to avoid damaging space environments as we venture further. Investments in technology through supportive policies can enhance our capabilities for exploration. Exploring the universe's boundaries often requires advanced tools and spacecraft, and government funding can spark innovation in these areas. By prioritizing scientific research and development, policies can lead to groundbreaking advancements that further our understanding of distant galaxies and the very nature of space itself. Finally, public engagement through education and outreach is vital. Policies that promote awareness and interest in space exploration can inspire the next generation of scientists and engineers. As more individuals become invested in space science, the momentum for exploration will grow, pushing the boundaries of what we currently know. Each policy decision, whether it focuses on international cooperation, sustainability, technological support, or public engagement, shapes our path forward in the expansive journey through the universe. International collaboration is vital for expanding our understanding of the universe. When countries work together, they combine their unique strengths, resources, and expertise, creating a powerful synergy that enhances exploration efforts. Consider how scientific knowledge builds on itself. Scientists from around the world share their research, enabling each other to benefit from discoveries made in different places. This exchange of ideas allows for quicker advancements and more innovative solutions to complex problems. Moreover, space missions are incredibly costly and complex. By sharing the financial burden, countries can fund larger, more ambitious projects that would be impossible for single nations to undertake. Think about the International Space Station, a remarkable example of collaboration where multiple countries contribute to living, working, and conducting research in low Earth orbit. This cooperation not only fosters scientific progress, but also strengthens political and cultural ties among nations. Working together also promotes a diverse range of perspectives, which can lead to richer scientific inquiries. Different cultures bring different questions and approaches to understanding the universe. For example, when designing a mission to explore a distant planet, varied views on what data is most valuable can help shape a more comprehensive mission plan. International collaboration unlocks the door to a more connected and cooperative approach to exploring the universe. It allows humanity to tackle the vastness of space as a united front, maximizing the potential for discovery and innovation in our quest to explore the limits of what lies beyond our world. The study of cosmic origins is deeply intertwined with our quest to understand the boundaries of the universe. To grasp this connection, we must first consider how we came to exist in the vastness of space. Scientists delve into the early moments after the universe began, exploring what happened during the Big Bang, a monumental event that marked the birth of everything we know. Understanding these origins helps us comprehend the universe's evolution, including the formation of galaxies, stars, and planets. As we uncover the secrets of how the universe started, we also seek out its limits. One might envision the universe as an ever-expanding balloon. In this analogy, the surface of the balloon represents the universe we see, stretching further as it inflates. By studying cosmic origins, we learn about the initial conditions that initiated this expansion and how it affects the distances between galaxies over time. This leads us to contemplate concepts such as the observable universe, the region from which light has had time to reach us since the beginning of time. Beyond this observable edge lies an unknown expanse that continues to intrigue and challenge scientists. The study of cosmic origins aids in understanding how far we can see and what might lie beyond. For instance, examining the cosmic microwave background radiation gives us a glimpse into the very early universe and helps establish a framework for its current limits. Ultimately, the relationship between cosmic origins and the universe's boundary combines aspects of cosmology, physics, and astronomy, allowing scientists to piece together not just how the universe began, but how it continues to evolve and where it might lead us in the vast unknown ahead. This journey reflects our deep desire to understand our place within the universe, seeking answers that lie both at the beginning and the edges of existence. Theories about the ultimate fate of the universe lead us to intriguing ideas about its edges and boundaries. To begin, consider the universe as an ever-expanding entity, much like a balloon inflating. As galaxies move away from each other, the question arises, does the universe have an edge, or is it boundless? Some theories suggest that our universe could continue expanding indefinitely, which implies that the concept of an edge might be misleading. Imagine if the universe is shaped like the surface of a balloon. If you were walking on it, you would never fall off an edge because every step takes you further along the curve. This suggests that even if the universe expands forever, it could still be a closed system without a definitive edge leading to emptiness. In contrast, other theories propose that the universe could face a dramatic end, possibly collapsing back into itself or reaching a state of heat death where energy disperses completely. These scenarios highlight a cyclical nature of existence, where the universe undergoes rebirths and deaths, suggesting that an edge could exist at various points throughout cosmic time. Further still, ideas like the Big Crunch or Big Rip provide different perspectives. The Big Crunch envisions a universe that reverses its expansion and ultimately collapses, while the Big Rip imagines a force pulling everything apart so rapidly that galaxies, stars, and even atoms are torn asunder. Each of these theories implies that understanding any edge would not only be about location, but also about the very nature and fate of existence itself. Ultimately, contemplating the universe's fate opens a doorway to questions about not just where its edges might reside, but also the nature of reality, existence, and even time itself in the face of cosmic change. Each theory invites us to rethink our understanding of the universe, reminding us that the edge is as much about the journey and unfolding story of the cosmos as it is about physical boundaries. The study of early galaxies provides a unique window into the universe's past, helping us understand how it evolved from a dense, hot state right after the Big Bang to the vast cosmos we see today. Imagine looking out into the night sky and seeing only faint, distant lights. Those lights are the early galaxies. These galaxies formed when the universe was still young, and their light carries essential information about the conditions at that time. By examining the light from these early galaxies, scientists can learn about the composition of the universe and how matter clumped together to form stars and galaxies. This reveals important elements that were present in the early stages of the universe, which can help us map out the initial conditions of cosmic evolution. Understanding these galaxies allows us to piece together the timeline of formation and growth, shaping our comprehension of the universe's structure. Moreover, studying early galaxies can also shed light on dark matter and dark energy, which make up most of the universe but remain mysterious. These galaxies provide clues about how these unseen components influence the universe's expansion and its overall fate. As we analyze the characteristics of these ancient galaxies, we gain insights into the rate of star formation and the processes that drive galactic evolution. This knowledge can help astronomers build more accurate models of the universe and its edge, essentially informing us about how the universe is structured and how it might continue to change. Understanding where galaxies formed and their distribution helps us define what we mean by the edge of the universe, both in terms of space and in our grasp of cosmic history. Everywhere we look in the universe, we see galaxies stretching out into the distance, giving us a snapshot of what exists in our observable universe. However, beyond this edge lies a mystery. The observable universe is like a view from a window. We can only see what is accessible within a certain distance from us. Beyond that, the universe likely continues, perhaps infinitely, but we can't see it or know for sure what lies there. One possibility is that regions beyond our view contain more galaxies, stars, and worlds that we cannot currently detect due to the limits of light travel. Since light takes time to journey through space, the farthest light we see comes from events that happened billions of years ago. This means that while we gaze into space, we are also looking back in time. Beyond this cosmic horizon, the universe could have changed dramatically, potentially filled with structures and cosmic phenomena unknown to us. Another intriguing idea is that the universe could consist of many separate regions or bubbles, each with its own properties and physical laws. This suggests a multiverse where each bubble stands alone, shielded from the others. If this is true, there could be entire universes that operate with different rules of physics, making the reality beyond our observable universe even more fascinating. Furthermore, theories in modern physics imply that the universe could be curved or looped, meaning traveling far enough in one direction could lead you back to your starting point. This raises questions about the nature of space itself and how interconnected the universe might be. While the boundaries of our visible universe limit our current understanding, the potential destinations that lie beyond are filled with endless possibilities, from familiar galaxies to entirely different realms governed by different rules of existence. The unknown stretches out, inviting curiosity and exploration, even if we may never fully penetrate that veil. Cosmic timelines are fundamental to understanding the history and structure of the universe. Imagine these timelines as a vast map that charts the key moments of the universe's existence, from the Big Bang to the present day. By breaking down this history into distinct eras, scientists can study how the universe evolved over time. When astrophysicists investigate cosmic timelines, they look at events such as the formation of the first stars, the birth of galaxies, and significant periods like the Age of Reionization. Each of these milestones marks not just a point in time, but also specific changes in the universe's composition and behavior. As galaxies formed and evolved, they created the gravitational forces that influenced the arrangement of matter in space. These timelines help scientists place boundaries on our understanding of the universe. By examining light from distant galaxies, we can glimpse what the universe looked like billions of years ago. This light contains information about its age and the state of cosmic structures at various points in time. By understanding when and how these structures formed, astronomers can outline the limits of the known universe, which we refer to as its borders. Moreover, cosmic timelines reveal how the universe is expanding. The rate of this expansion changes over time, which means the universe itself is continually evolving. This expansion contributes to our comprehension of the universe's ultimate fate, whether it will continue to grow forever or experience a dramatic end. Cosmic timelines provide an essential framework for studying the universe. They not only map the events of its past, but also offer insights into its current boundaries and future. By piecing together these moments, scientists can better understand the complexities of our universe and its ongoing story. Mathematics plays a crucial role in helping us understand the edge of the universe, or rather, our concept of it. To begin with, we need an idea of what we mean by the edge. Although it may seem straightforward, the universe is incredibly complex. Instead of thinking of it as a flat space with a boundary, scientists use various mathematical models to describe its shape and expansion. One of the key concepts here is the idea of space expanding. Imagine blowing up a balloon. As the balloon gets bigger, points on its surface move away from each other. Similarly, mathematicians model our universe using geometry and equations that describe how galaxies move apart over time. These models reveal that the universe is not just expanding but is also curved, almost like the surface of our imaginary balloon. Using mathematics, particularly the field of geometry and calculus, scientists can calculate distances and shapes in this expanding universe. They apply equations to predict how far light travels, how galaxies shift positions, and how much time has passed since the Big Bang. All of this helps establish a sort of edge, not a physical barrier, but a boundary of observable information. Essentially, the limit of what we can see and detect, influenced by the speed of light and the age of the universe, defines our observable edge. Beyond this point, light from other galaxies has not had enough time to reach us since the universe began. Therefore, mathematics allows us to frame our understanding of the observable universe and continue exploring the mysteries that lie beyond. Einstein's theory of relativity revolutionized our understanding of space, time, and gravity, and it's crucial for exploring the concept of the universe's boundary. At the heart of his theory are equations that describe how mass and energy influence the fabric of spacetime, creating a dynamic relationship between the three. Imagine spacetime as a stretchy sheet. When you place something heavy, like a planet or a star, on that sheet, it creates a dip or curve. This curvature affects how objects move through space. The equations help scientists understand how this produces gravity, which is not just a force pulling objects together, but a way of describing the path that matter follows in curved spacetime. When it comes to the universe's boundary, these equations provide insights into how space expands and contracts. According to the theory, the universe is not static. it's continually evolving. The equations can even describe how objects behave near the edge of the observable universe, which we consider as a boundary. This boundary isn't physical, but is based on what we can see, limited by the speed of light and the age of the universe. Moreover, these equations suggest that the universe could be finite or infinite. If it's finite, then at a certain distance, the fabric of space might loop back on itself. This would mean if you were to travel far enough in one direction, you could end up back where you started. On the other hand, if the universe is infinite, it could go on forever, presenting challenges in understanding what lies beyond our visible horizon. Einstein's equations thus illuminate a lot about the universe's structure, guiding us in our quest to comprehend our cosmic landscape, its limits, and what might lie beyond them. Each revelation stands on a foundation of scientific exploration, encouraging us to think about the universe not just in terms of distances, but as a complex interplay of time, space, and energy. To theorize about the universe's edge, scientists employ several mathematical models that help to unravel the mysteries of space. One prominent model is the concept of cosmic inflation. This theory posits that just after the Big Bang, the universe expanded exponentially, growing immensely in a short amount of time. This rapid expansion helps explain the uniform distribution of galaxies we observe today. Another essential model is the Friedmann-Lemaitre-Robertson-Walker metric. This framework describes a universe that is either expanding or contracting. By considering various shapes of the universe, including flat, open, and closed configurations, scientists can better understand the overall structure and potential boundaries of the cosmos. Additionally, the concept of the observable universe comes into play. This model describes the limitation of our view of the universe based on the speed of light. Since light takes time to travel, we can only see parts of the universe that are within a certain distance from us. This does not mean the universe has an edge in the traditional sense, but rather that there are regions we cannot currently observe due to the finite speed of light. Another noteworthy exploration is the idea of a multiverse. Some theories suggest there may be many universes, each with different properties. This expands our understanding of edges beyond a single universe to consider how our universe might differ from countless others. These mathematical models serve as tools that help astronomers and physicists envision how the universe might behave at its very edges and what lies beyond our current observational capabilities. Each model contributes uniquely, piecing together a more comprehensive image of the vast cosmos we seek to understand. Mathematical innovation has played a crucial role in transforming how we view the vast universe and its boundaries. Imagine trying to understand a massive puzzle without the right tools. Mathematics provides those necessary tools, allowing scientists to decode the mysteries of the cosmos. When we began exploring concepts like infinity or the curvature of space, mathematics opened doors to greater insights. For instance, the introduction of calculus allowed scientists to describe how objects move and how gravity affects them, leading to a clearer understanding of orbits and the dynamics of planetary systems. This mathematical framework helped formulate theories such as Newton's laws of motion and Einstein's theory of general relativity. These theories reshaped our perception of space and time, showing that they are interconnected and can curve in the presence of mass. As we moved deeper into the cosmos, specialized forms of mathematics revealed even more complex ideas. For example, topology, the study of shapes and spaces, allows scientists to consider the universe in terms of its structure without focusing on exact measurements. This has opened discussions about concepts like multiple dimensions and the shape of the universe itself. Mathematical models have also allowed us to explore cosmic phenomena, such as the behavior of black holes. Through equations derived from mathematical principles, we've gained insights into how these objects form, their effects on surrounding matter, and their relationship to time. This has impacted our understanding of cosmic limits, suggesting that certain regions may be unreachable or exist beyond our frame of reference. The evolution of mathematical thinking has profoundly reshaped our understanding of cosmic limits. It has equipped us to grasp the intricacies of the universe, revealing that what we perceive as boundaries may, in fact, be gateways to new realms of knowledge and adventure. Chaos theory helps us grasp the complexity within the universe, even in its seemingly ordered structures. Imagine a butterfly flapping its wings. creating tiny changes in the atmosphere that might lead to a distant tornado. This simplistic idea illustrates how small actions can lead to vastly different outcomes. In the context of the universe, chaos theory suggests that just as the weather is highly sensitive to initial conditions, cosmic events can also behave unpredictably. When we look at the universe's boundaries, we are confronted with various factors, like dark matter, dark energy, and the expansion of space itself. Traditionally, scientists believed the universe followed a steady, predictable pattern. However, chaos theory introduces the possibility that minute variations in these cosmic factors could lead to unforeseen results. For example, the dynamics of galaxies merging or the behavior of cosmic strings, hypothetical defects in space-time, might not follow a clear path, but could instead be influenced by chaotic interactions. This perspective shifts our understanding of what the universe's limits might be. Instead of a neatly contained system with straightforward behavior, we see a tapestry of interconnected elements that can amplify changes, leading to diverse and unpredictable outcomes. By recognizing the chaos inherent in these interactions, we open the door to exploring new theories about the universe's structure and evolution, highlighting that the edges of our understanding are not just boundaries, but evolving areas filled with potential surprises. In this way, chaos theory provides a deeper insight into the complexities and mysteries that define our cosmos. Science fiction often ventures into the idea of the universe's edge by weaving imaginative narratives that challenge our understanding of reality. This concept is intriguing because it raises fundamental questions about what lies beyond our observable universe. In many stories, the universe's edge is depicted as a literal boundary or a mysterious frontier, a place where the known laws of physics might not apply, and where the very fabric of space and time could unravel. Many sci-fi authors choose to explore this edge as a portal to other dimensions or realities. Picture a vast, dark expanse where existing theories break down, and travelers might encounter alternate worlds or unique phenomena that don't fit into our current scientific models. For instance, characters might step into this edge and find themselves in a universe governed by different physical laws, or even in a realm where time behaves erratically. Moreover, the notion of an edge often serves as a metaphor for human exploration and the quest for knowledge. It represents the limits of our understanding and the courage required to push beyond those limits. Characters in these stories might embark on epic journeys to seek out the edge, confronting great risks and uncertainties. This reflects humanity's innate desire to explore the unknown and confront what may exist outside our perception. In some tales, the edge of the universe might be portrayed as an infinite void or a connecting point for different universes, emphasizing themes of connection and parallel existences. These narratives allow for a rich exploration of existential questions, hinting at the possibility that there could be more to existence than what we can currently comprehend. Ultimately, science fiction serves not only to entertain, but also to expand our imagination regarding the universe's potential. By reflecting on the universe's edge through creative storytelling, these works invite us to ponder the mysteries of existence and the future of our cosmic journey. Speculative science fiction has played a significant role in shaping people's imaginations about the universe and the boundaries of scientific exploration. Through its vibrant storytelling, science fiction presents ideas that, while imaginative, often push the envelope of current scientific understanding. These narratives invite curiosity about what lies beyond our own world, sparking interest in fields like astrophysics, cosmology, and even space engineering. Consider the concept of faster-than-light travel, often portrayed in books and films. This idea encourages scientists and engineers to think creatively about advanced propulsion methods and theories in physics that might one day turn fiction into reality. For instance, the notion of warp drives or wormholes promotes discussions about the fabric of space-time and the potential for shortcuts through vast distances. While these ideas remain theoretical, they lead to serious scientific inquiries, inspiring research that explores the limits of technology and our understanding of the universe. Moreover, science fiction has the power to captivate the public's imagination, creating a culture that values exploration and discovery. This enthusiasm can drive funding and support for scientific research. When audiences are engaged with a compelling narrative about space and the unknown, they tend to feel a stronger connection to real-world science and its potential applications. Movies like Interstellar or series like Star Trek have not only entertained but also informed and inspired new generations of scientists and engineers to pursue careers in space exploration. Furthermore, speculative science fiction often grapples with the ethical implications and societal effects of advanced scientific advancements. By exploring potential futures, these stories provide a platform for discussions about the responsibilities we may hold as we venture further into the cosmos. This dialogue can influence the direction of scientific research, ensuring that as we explore, we also consider the consequences of our discoveries. Speculative science fiction acts as both a source of inspiration and a catalyst for real scientific inquiry. It encourages dreamers to ask, "What if?" prompting researchers to pursue new frontiers. Through its blend of creativity and inquiry, science fiction continues to illuminate possibilities, urging us to seek answers about our place in the universe and the limits of our understanding. Throughout history, authors have used their imaginations to explore what lies beyond the edge of the universe, often reflecting the mysteries and wonders of the unknown. Many early stories considered the universe to be a finite space enclosed by a boundary, leading to speculation about what might exist beyond that limit. Some envisioned a mystical realm filled with gods or supernatural beings overseeing human existence. As scientific knowledge evolved, so did the narratives. In the early 20th century, authors began to incorporate concepts from emerging theories in physics and cosmology. H.G. Wells, for instance, explored themes of time travel and parallel worlds, suggesting a more fluid understanding of space beyond what we can currently see. This laid the groundwork for imagining that the universe could extend infinitely, filled with alternate realities and dimensions. The concept of a multiverse, where multiple universes coexist with different physical laws, gained popularity in literature during the late 20th century. Writers like Arthur C. Clarke and Isaac Asimov penned stories where characters ventured into realms beyond our universe, often facing the implications of encounters with entirely different forms of life and civilizations. These narratives not only sparked intrigue, but also posed philosophical questions about existence and our place in the cosmos. Today, even as we gain a clearer understanding of the universe through scientific advancements, the portrayal of what lies at its edge remains a fascinating blend of imagination and science. Authors continue to play with ideas of the infinite, exploring the boundaries of reality through speculative fiction. They invite readers to ponder whether there is something truly beyond, and if so, what it might mean for humanity's journey into the stars. This interplay between fiction and scientific inquiry keeps the question alive, urging us to look to the heavens with wonder and curiosity. Cinematic representations of the universe often delve into its boundaries through imaginative storytelling and stunning visuals that captivate the audience's imagination. Films and documentaries present the concept of the universe's edge in various ways, frequently using grand visuals of galaxies, nebulae, and infinite stars. These images spark curiosity about what lies beyond what we can see. One common theme is the idea of exploring the unknown, represented by spacecraft journeying into the depth of space. This exploration is not just physical but also philosophical, as it raises questions about existence, the nature of reality, and what it means to reach the limits of our universe. Movies might depict characters venturing to places where the laws of physics seem to bend or fail, emphasizing the boundary between known science and the unexplainable. Additionally, filmmakers often illustrate the universe's edge as a mental construct, portraying the boundaries of human knowledge. They play with concepts like black holes or wormholes, suggesting that what we perceive as an end might just be a doorway to new dimensions or parallel realities. This blend of scientific theories with storytelling pushes viewers to think critically about where our understanding of the universe ceases and what lies beyond that threshold. Through this artistic lens, cinema doesn't just entertain. It invites audiences to ponder profound questions, explore human curiosity, and imagine the possibilities waiting at the universe's edge, fostering a deeper connection to the cosmos. Speculative fiction has played a significant role in shaping how people think about the universe and its boundaries. This genre includes stories about space exploration, alien civilizations, and futuristic technologies, which inspire curiosity and imagination about what lies beyond our planet. Authors create vivid worlds where the impossible becomes possible, prompting readers to consider ideas they might never have thought of otherwise. One common theme in speculative fiction is the concept of infinite worlds. Stories often present the universe as a place full of unknown galaxies and uncharted territories, suggesting that space is limitless. This notion challenges the idea that we have explored everything there is to know about our cosmos. It encourages a sense of wonder and pushes humanity to dream big, instilling the belief that we may one day leave our solar system and reach distant stars. Moreover, speculative fiction frequently introduces advanced technology and alien life. These concepts help people visualize potential futures where we could communicate with intelligent beings from other planets or travel at remarkable speeds. By showcasing these possibilities, authors influence public perception about the feasibility of such endeavors, stirring interest in real scientific efforts like space travel and the search for extraterrestrial life. Ultimately, speculative fiction acts as a bridge between science and imagination. It makes complex ideas more approachable, sparking public interest in science and creativity alike. This blend encourages audiences to question history, future possibilities, and the vastness of the universe, making the exploration of these topics not just a scientific pursuit, but a journey of human creativity and aspiration. The intersection of art and science offers a unique lens through which we can explore the universe's edge. Art has the ability to convey complexities and invoke emotions in ways that pure data cannot. When artists collaborate with scientists, they interpret scientific discoveries through imaginative visuals, sounds, and narratives, making abstract concepts more tangible and relatable. For instance, an artist might visualize a black hole or the birth of a star, transforming scientific descriptions into visual masterpieces. This can help the public grasp ideas that are otherwise challenging to understand, such as the vastness of space or the idea of time distortion near massive objects. Engaging artistic representations turn intricate scientific phenomena into experiences that resonate on a personal level. Additionally, science often relies on creativity to formulate theories and design experiments. Artists and scientists share a crucial commonality. Both require curiosity and innovation. When they come together, they create new insights that neither could achieve alone. For example, an exhibit that combines images from deep space, sculpture, and interactive installations invites participants to consider the mysteries of the universe in a multidimensional space. Moreover, this collaboration can deepen our questions about existence. Art compels us to reflect on what the universe means to us as individuals and as a society. It encourages us to contemplate not only the scientific facts about the universe's edge, but also our own human experience within it. The intersection of these disciplines thus serves as a powerful medium for exploring the profound and often philosophical implications of what lies beyond the observable universe. Philosophical approaches play a vital role in shaping scientific inquiry into the universe's boundary. At their core, philosophy encourages deep questioning about existence, reality, and the nature of knowledge itself. When scientists contemplate the edges of the universe, they do not just rely on empirical data. They also engage with profound questions that guide their exploration. Philosophical inquiry helps define what we mean by the universe and its boundaries. Is it merely the observable sky, or does it extend beyond our perception? This distinction is crucial because it influences what scientists choose to study and how they interpret their findings. Philosophers also explore concepts like infinity and the nature of time, which are essential when considering if the universe has an edge or if it is boundless. Moreover, different philosophical perspectives can lead to different scientific hypotheses. For example, discussions about determinism, whether all events are predetermined or influenced by random factors, directly impact theories about the universe's initial conditions and its evolution. The way we frame questions about the universe's beginning, such as the Big Bang, stems from philosophical ideas about causality and existence. Lastly, the limitations of scientific inquiry also emerge from philosophical discussions. Questions about what we can know or measure prompt scientists to reconsider methods and technologies. They challenge researchers to think about the role of observation versus theory and whether certain phenomena could ever be understood or witnessed. Philosophy acts as a foundation upon which scientific exploration is built. It invites curiosity, shapes inquiry, and challenges the boundaries of our understanding, ultimately enriching the quest to unlock the mysteries of the universe and its boundaries. The history of humanity's understanding of the universe profoundly shapes contemporary theories about its boundaries. In ancient times, people looked at the stars and created myths to explain celestial phenomena. The sky was seen as a dome or a ceiling, giving a practical framework but limiting our understanding. As civilizations progressed, thinkers like the ancient Greeks began to provide more formal theories, suggesting that the Earth was a sphere and that celestial bodies revolved around it. This marked a significant step toward a more refined view of the cosmos. During the Renaissance, the revolutionary ideas of figures like Copernicus and Galileo challenged the idea of Earth at the center of the universe. They proposed that planets orbit the sun. This shift did not merely change positions, it ignited questions about the vastness of space, leading to the realization that the universe might be much larger than previously imagined. The idea that Earth is just one of many worlds opened the door to concepts of a broader cosmos. As time progressed, the invention of telescopes allowed astronomers to observe deeper into space. The discoveries of distant galaxies and the vastness beyond our solar system made it clear that the universe had no easily discernible edge. This ambiguity about the universe's limits continued with the theory of relativity in the early 20th century, which introduced mind-bending concepts about space and time. It suggested that the universe was not static but expanding, leading to more questions about its ultimate extent. Contemporary theories, such as those surrounding dark energy and cosmic inflation, reflect this rich historical context. They emerged from a growing body of evidence and the need to explain observed phenomena, like the accelerating expansion of the universe. Scientists now contemplate not just the universe's boundaries, but also whether there might be other parallel universes or dimensions beyond our understanding. Thus, history influences our current theories by building a foundation of curiosity, shifting paradigms, and expanding our understanding. Each idea, whether validated or overturned, contributes to an ever-evolving picture of the cosmos and invites us to explore even further into the unknown. The quest for understanding the universe's limits is not just a scientific endeavor. It is a journey through humanity's rich intellectual history. Cultural interpretation plays a significant role in how we understand the universe's edge, which can be seen as a metaphorical and literal boundary of existence. Different cultures have unique perspectives and stories regarding the cosmos, often shaped by their histories, beliefs, and practices. For instance, some cultures view the universe as a living entity, with the stars and other celestial bodies being viewed as ancestral spirits or gods. This influences how these cultures perceive the edge of the universe, perhaps as a sacred space rather than just a physical boundary. In modern science, the edge of the universe can refer to the limits of what we can observe. This scientific perspective is influenced by technological advancements. However, the cultural lens can add depth to our understanding by infusing the starkness of scientific facts with rich narratives. For example, many people are drawn to concepts of creation myths, legends, or religious beliefs that offer a story about how everything came to be. Furthermore, how we visualize the universe's edge can vary widely. Some cultures might see it as a flat horizon, while others might imagine it as a great cosmic ocean with vast unknowns beyond the sight of telescopes. This framing can shape how we approach scientific inquiry, leading to a more holistic understanding of our place in the cosmos. As we strive to understand the universe, blending scientific understanding with cultural interpretations can create a more comprehensive view. This combination allows for a dialogue between science and culture, enhancing our curiosity and appreciation for the mysteries that lie at the edges of our knowledge. Ultimately, these diverse perspectives can spark inspiration, motivating individuals to explore the universe and question what it truly means to reach its vast boundaries. Interdisciplinary collaboration is a powerful catalyst for breakthroughs in our exploration of the universe. When experts from different fields come together, they bring unique perspectives and skills that can address complex questions and challenges. For instance, combining the insights of astronomers who study celestial objects with engineers who design space probes creates a more robust approach to developing new technologies for space travel. Imagine a team where astrophysicists work alongside biologists. This partnership could lead to innovative methods for detecting signs of life on distant planets. The astrophysicists understand the behaviors of stars and the conditions of exoplanets, while biologists contribute their knowledge of life on Earth and what forms it might take elsewhere. By merging these insights, the team can propose more effective experiments and missions. Additionally, artists and communicators can play a critical role in making scientific findings accessible. Their ability to translate complex data into engaging stories and visuals can captivate the public and inspire future generations of scientists. This outreach also encourages support for funding and policies that drive exploration. Furthermore, interdisciplinary collaboration fosters a culture of creativity and innovation. When scientists and engineers from various backgrounds work together, they often think outside traditional boundaries. This environment can lead to unexpected and groundbreaking solutions, such as new propulsion methods or instruments that can probe deeper into space than ever before. The union of diverse disciplines not only enhances problem-solving capabilities, but also enriches the quest for knowledge about the universe. Each voice contributes a piece to the puzzle, enabling humanity to explore further and understand our place in the cosmos more deeply. Enhancing public education about the universe's boundaries can start with making complex subjects more engaging and accessible. One effective approach is to utilize visual aids like documentaries, interactive planetarium shows, and digital simulations that illustrate the vastness of space. These tools help students and the general public visualize abstract concepts, such as the scale of the universe or the nature of cosmic phenomena. Incorporating hands-on activities can also deepen understanding. For example, organizing stargazing events or model-building workshops allows participants to explore celestial objects directly or construct representations of galaxies, solar systems, and other cosmic structures. This tactile experience strengthens connections with the material. Curriculum development is another critical area. Educators can integrate topics about the universe into science classes, emphasizing not just facts, but also the process of scientific inquiry. Students should be encouraged to ask questions about what lies beyond the observable universe and explore theories surrounding dark matter and dark energy as part of their learning. Collaboration with local astronomical societies, science museums, and universities can create a bridge to expert knowledge. Guest lectures, workshops, and outreach programs bring real-world scientific experiences into the classroom, providing students with a glimpse into the work of astronomers and cosmologists. Furthermore, leveraging technology, such as virtual reality experiences that simulate cosmic exploration, can captivate interest. These experiences allow learners to travel to different parts of the universe, making distant concepts more relatable and stirring curiosity. Lastly, promoting scientific literacy through community events and social media campaigns can spark public interest in astronomy. By sharing exciting discoveries and inviting discussions, the general population can become more informed about the universe's vastness and the ongoing exploration beyond our planet. This multifaceted approach can cultivate a well-informed public that appreciates the wonders of the universe and recognizes the importance of continued exploration and understanding. Museums and planetariums serve as gateways for people to explore the universe's mysteries and wonders. They act as education hubs where the vastness of space and the complexities of our cosmos come to life. Museums often house fascinating exhibits filled with artifacts from space missions, models of celestial bodies, and interactive displays that explain astronomical phenomena. Here, visitors can engage with the content, exploring everything from the history of space exploration to understanding the life cycles of stars. Planetariums take this experience to a different level by immersing visitors in the night sky. Inside a planetarium, a domed screen projects stunning visuals that depict constellations, planets, and cosmic events. This captivating environment encourages awe and curiosity. As the stars whirl and galaxies form on the ceiling, the audience learns about the mechanics of the universe, like how gravity shapes our experiences or how light years measure vast distances. Both institutions also serve to inspire the next generation of scientists, engineers, and explorers. Programs geared toward children and adults alike foster a sense of wonder and inquiry. Workshops, lectures, and special events invite participants to engage in discussions about the latest discoveries in astrophysics, the search for extraterrestrial life, and even the ethics of space exploration. In this way, museums and planetariums play a crucial role in making the complexities of the universe accessible and understandable. They ignite passion for space science, build knowledge, and encourage a sense of community among those fascinated by what lies beyond our planet's boundaries, helping everyone appreciate the incredible journey we're all a part of in exploring the universe's edge. Documentaries have a unique power to draw in audiences by exploring the vast and often mysterious limits of the universe. They engage viewers by presenting complex scientific ideas in an accessible way, allowing people to grasp concepts that might seem daunting at first. This captivating journey often begins with stunning visuals of space, from shimmering galaxies to the swirling dance of distant stars. These images spark curiosity and wonder, inviting viewers to imagine what lies beyond our world. Narration plays a crucial role in guiding the audience through intricate topics, helping to simplify and explain the phenomena that define the universe's boundaries. The storytelling aspect of documentaries allows the audience to connect emotionally with the content, framing scientific discoveries within a larger narrative about exploration and human understanding. By weaving together personal stories of scientists, historical contexts, and revolutionary theories, these films bring an element of relatability to grand cosmic questions. Additionally, documentaries provide a stage to discuss profound and philosophical inquiries, like the nature of black holes, the concept of dark matter, and the potential for other dimensions. By presenting these ideas in an engaging format, viewers are encouraged not only to learn but to think critically about the limits of our knowledge. The combination of visuals, narratives, and expert insights inspires a sense of wonder and curiosity, motivating audiences to consider their place in the universe and the mysteries that remain unsolved. Through this blend of entertainment and education, documentaries can spark imaginations and encourage discussions about our cosmic journey, reminding us that although we may face limits in our understanding, the pursuit of knowledge is an unending adventure. Engaging the public in discussions about the universe's edge can be both enlightening and exciting. One effective approach is to create visually captivating events, such as exhibitions or planetarium shows, where dramatic images and animations illustrate the vastness and complexity of the universe. These visuals can spark curiosity and invite stories about people's connections to space. Another way is to use storytelling. Sharing fascinating stories about explorers of the cosmos, like astronomers who have made groundbreaking discoveries, makes the science relatable. Personal stories about the human quest for knowledge can resonate deeply and foster a sense of shared adventure. Interactive activities are also powerful. Workshops or science fairs where people can participate in demonstrations, such as building their own small-scale models of galaxies or discussing concepts like dark matter, transform abstract ideas into tangible experiences. This hands-on involvement encourages dialogue and deeper understanding. Utilizing social media platforms effectively captures interest too. Engaging posts or videos that challenge misconceptions about the universe or present mind-boggling space phenomena can prompt discussions. Simple questions about the universe's edge can lead to profound conversations. Additionally, collaborating with schools to incorporate topics about the universe into lessons provides early engagement. Children who learn about cosmic wonders are more likely to appreciate and discuss these ideas as adults. Finally, hosting public lectures or panel discussions featuring scientists who can explain complex ideas in plain language invites the community to ask questions and feel connected to ongoing research. By blending education, interaction, and storytelling, conversations about the universe's edge can ignite passion and curiosity in people of all ages. Virtual reality, or VR, presents an exciting way to explore the universe's vastness and complexities. Imagine being immersed in a three-dimensional simulation that allows you to float through space. In this environment, you can observe celestial bodies like stars, planets, and galaxies firsthand. This immersive experience captures attention much more effectively than traditional learning methods. When learning about the boundary of the universe, VR can visualize concepts that are otherwise abstract. For instance, you could virtually travel to the edge of the observable universe, where light from the earliest stars and galaxies can be seen. In a VR setting, you would not just read about this phenomenon, you would witness it, enhancing understanding through visual experience. Additionally, VR allows learners to engage actively. Users might manipulate elements of the universe, such as moving through black holes or interacting with cosmic phenomena, making abstract ideas more tangible. This participation can solidify memory retention, as learning becomes an adventure rather than a passive activity. Teachers can also guide virtual experiences, explaining complex theories of cosmology as students explore. As the learners move through this virtual cosmos, they gather knowledge about the universe's structure, size, and the laws governing it in a manner that combines education with engagement. Virtual reality transforms our perception of the universe's boundaries, making learning immersive and thrilling. It brings abstract cosmic concepts to life, sparking curiosity and deepening understanding in ways that traditional classrooms cannot match. The exploration of the universe's edge symbolizes humanity's intrinsic quest for knowledge and understanding. This drive stems from an innate curiosity, a fundamental trait that defines our species. Picture early humans gazing up at the stars, pondering questions like what lies beyond the horizon and whether we are alone in this vast cosmos. As we have advanced, so too has our ambition to push the limits of our understanding. Venturing to the boundaries of the universe raises profound questions about existence itself, and the laws that govern reality. Scientists and astronomers work tirelessly, sending spacecraft to distant planets and deploying powerful telescopes that capture the faintest whispers of light from ancient galaxies. Each discovery at the fringe of the known universe not only unravels the mysteries of space, but also reflects our collective spirit to seek answers. This exploration fuels a sense of connection to something greater than ourselves, urging us to explore further and understand our place in this magnificent yet daunting universe. Moreover, the challenges faced during these explorations showcase our resilience and determination. Every mission carries risks, whether it is launching a probe to the far reaches of the solar system or attempting to observe cosmic events that occurred billions of years ago. These endeavors demand teamwork, innovation, and an unwavering belief in our ability to glean knowledge from the unknown. In this way, the pursuit of exploring the universe's edge mirrors our deepest desires to discover, to learn, and ultimately, to find meaning beyond the stars. Contemplating the universe's boundary leads us to profound questions about our existence and place in the cosmos. Imagine the universe as a vast ocean. On a beach, you might wonder what lies beyond the horizon. The universe's boundary, if one exists, represents the limit of our current understanding. Exploring these edges challenges our perceptions and ignites curiosity about what lies beyond and what that could mean for our lives. When we think about the universe's limits, we start to grapple with concepts like infinity and the nature of reality. If the universe is infinite, it suggests that possibilities are endless, not just for other worlds, but for the experiences we can have. Conversely, if the universe does have a boundary, it could imply a larger framework in which everything exists, making us consider what is beyond our universe and whether there are other dimensions or realities. This contemplation also brings to light the origins and fate of our universe. Encountering questions about how everything began and what will happen in the future prompts a deeper reflection on existence. It connects us to cosmic events, such as the Big Bang, leading to consideration of our own life stories in the grand timeline of the universe. Moreover, these thoughts can cultivate a sense of unity with the cosmos. When we ponder the immensity of the universe, we recognize how small yet significant our lives are. This realization can foster a connection to each other and to the natural world. As we seek to understand our place, we also reflect on our responsibilities to protect our planet and each other. Contemplating the universe's boundary enriches our understanding of existence by challenging us to think about the nature of reality, our origins, and the connections we share in this vast expanse. This journey of exploration and inquiry becomes a fundamental part of being human, shaping our beliefs, values, and our future. The quest to understand the end of the universe is not just a scientific endeavor, it reflects our deepest human instincts and resilience. As we study cosmic phenomena, From the faintest stars to the vast dark cosmos, we confront profound questions about existence itself. This search reveals our innate curiosity and our determination to seek knowledge, even about the most unsettling topics. When scientists ponder scenarios like the ultimate fate of the universe, whether it will expand forever, collapse in on itself, or reach some other conclusion, they are also exploring the limits of our understanding. These theories challenge us to think beyond our immediate experiences and consider timescales that stretch billions of years into the future. This ability to envision what lies ahead shows our resilience. We are not deterred by uncertainty, but rather inspired to understand and adapt. Furthermore, examining the future of the universe brings us closer together as a species. Collaborating on complex projects such as telescopes and space missions fosters a shared purpose and unity. As we strive to grasp the mysteries of existence, we realize that while the universe may seem vast and indifferent, our exploration binds us in collective inquiry and hope. Ultimately, the quest serves as a reminder that even in the face of potential cosmic endings, our drive to understand, adapt, and persevere reflects the essence of what it means to be human. It teaches us that resilience is not only about survival, but also about our unwavering pursuit of knowledge and connection to one another. Exploring the universe's limits has profoundly shaped philosophical thought about what it means to be human. As we look outward into the vastness of space, we are compelled to confront our place within it. Historically, humans believed they were at the center of existence. However, discoveries of distant galaxies, the immense scale of cosmic structures, and the realization of countless stars have shifted this perspective. We are now seen as just a small part of a much larger universe. This shift has sparked deep questions about purpose and meaning. If our planet is just a speck in the grand cosmos, what significance do our lives hold? Philosophers discuss concepts of existence and the essence of humanity, grappling with the idea that life might be a rare occurrence in a universe full of inhospitable environments. This understanding implies a responsibility toward our planet and each other, urging us to cherish the fragile conditions that allow life to flourish. Furthermore, the idea of potential life elsewhere in the universe raises questions about the nature of intelligence. If we are not alone, it could challenge our notions of what it means to be intelligent or advanced. It pushes us to think about how we define ourselves in relation to other beings that might exist. This also touches on ethical considerations. How would we approach contact with extraterrestrial life, and what responsibilities would we bear toward them? The exploration of cosmic limits has encouraged a sense of unity as well. Seeing Earth from afar as a pale blue dot can evoke feelings of shared humanity. It emphasizes that we all share this small planet, making philosophical discussions about ethics, cooperation, and stewardship paramount. Our adventures into space invite us to rethink our values and consider the broader implications of our actions, not only for our own species, but for the universe as a whole. Our quest to understand the universe's boundaries motivates us to explore the very tenets of existence, identity, and morality, challenging us to broaden our views and deepen our appreciation for life in all its forms. The quest to reach or understand the universe's edge is viewed by society as a profound journey into the unknown. This endeavor reflects humanity's deep curiosity and desire to discover our place in the cosmos. Many people believe that exploring the boundaries of the universe can unlock secrets about the origins of existence itself, providing insights into who we are and how everything began. Reaching the universe's edge is often seen as an ultimate challenge. It represents the pinnacle of human achievement in science and technology. This pursuit captures the imagination, inspiring countless individuals to dream big, to pursue careers in science, engineering, and other fields that push the boundaries of knowledge. The idea of an edge, especially in a vast and ever-expanding universe, suggests a limit that, once reached, could reveal new dimensions of reality and even answers to fundamental questions about life, time, and space. In addition, understanding the universe's edge can have implications for our future. As we face challenges on Earth, such as climate change and dwindling resources, looking outward encourages the belief that solutions may lie beyond our planet. Many consider the exploration of space as essential not only for scientific advancement, but also for the survival of the human race. It's an opportunity to foster international cooperation as nations collaborate in shared scientific goals, highlighting that the universe belongs to everyone. However, there are also philosophical considerations. Some ponder the meaning of exploring the universe when so many mysteries exist on our own planet. This leads to debates about priorities, whether resources should be explored for outer space or redirected to address problems we face on Earth. Ultimately, society tends to view understanding the universe's edge as a dual journey. It is about expanding our scientific knowledge while also reflecting on what it means to be human in the grand tapestry of existence. It showcases the balance between seeking knowledge and making meaningful choices in the here and now. Quantum tunneling is a fascinating phenomenon in the world of quantum physics, where particles can pass through barriers that, according to classical physics, they shouldn't be able to cross. Imagine a ball rolling towards a hill. If it doesn't have enough energy, it would simply roll back. However, in the quantum realm, a particle has a chance of appearing on the other side of that hill, as if it somehow slipped through without needing to climb over. This concept has intriguing implications when discussing theories about the edge of the universe. Some scientists suggest that the boundaries of our universe could act as a barrier similar to that hill. In this scenario, quantum tunneling might allow particles or even information to escape what we perceive as the observable universe. This leads to speculation about what exists beyond our visible horizon. If particles can tunnel through barriers, could there be regions of the universe that lie just outside our view? This opens up possibilities for understanding new dimensions or parallel universes which may exist beyond the edge of our own. Some theories propose that every time a particle tunnels, it might connect different regions of space-time, hinting at a more intricate structure of reality than what we can see. The exploration of these concepts challenges our understanding and raises profound questions about the nature of existence. Though we cannot observe these tunneling events directly or the edges of the universe, the implications weave a tapestry of ideas that suggests our universe might be more interconnected and complex than we initially thought. As research in quantum physics and cosmology continues, these ideas will likely evolve, pushing the boundaries of our knowledge even further. Schrödinger's cat paradox is a thought experiment that explores the nature of quantum states in physics. In the scenario, a cat is placed in a sealed box with a device that can kill it based on a random quantum event. Until someone opens the box to look inside, the cat is considered both alive and dead at the same time, existing in a state of uncertainty. This paradox illustrates the strange behavior of particles on a quantum level, where they can exist in multiple states until observed. Now, how does this connect to the idea of understanding what lies beyond the universe's boundary? Imagine that the universe itself is like the sealed box. Just as the cat is both alive and dead until we check, what exists beyond our observable universe might be in a similar state of uncertainty. We have theories about the multiverse or dimensions beyond our own, but since we cannot yet observe them directly, they remain theoretical. This parallel suggests that, like the cat, the nature of reality beyond our universe could depend on whether we are able to measure or observe it. Without observation, these regions might be thought of as existing in a state of potentiality, with endless possibilities that only solidify into a specific reality when we find a way to observe or understand it. Therefore, Schrödinger's cat encourages us to think about limits of knowledge. It serves as a reminder that understanding the universe's boundary may be more complex than simply looking or measuring. It may also involve fundamentally different rules or states of existence that challenge our conventional perceptions of reality. This invites us to remain open to the unknown, where countless possibilities await, much like the fate of the cat until the box is opened. Quantum fluctuations are intriguing phenomena that arise from the principles of quantum mechanics, which describe how particles behave on a very small scale. At the heart of these fluctuations is the idea that empty space is not truly empty. Instead, it is filled with a constant activity of particle pairs popping in and out of existence. This spontaneous activity occurs even in the depths of the vacuum, leading to unpredictable changes in energy levels. When we consider the concept of the universe's edge, quantum fluctuations suggest that this edge is not as straightforward as it might seem. Traditionally, one might imagine the universe as a vast, homogeneous space with a clear boundary. However, quantum mechanics indicates that near any such boundary, there could be a continual ebb and flow of particles due to fluctuations. This means that the universe's edge, if it exists, would not present a hard stop, but rather an area full of potential activity. These fluctuations might also provide insights into the very creation of the universe. They are believed to have played a role in shaping the conditions that led to the Big Bang. Some scientists theorize that tiny quantum fluctuations in the early universe could have resulted in variations in density, which ultimately led to the formation of galaxies and other cosmic structures we see today. Thus, while we often think of the universe as a broad, infinite expanse, quantum fluctuations challenge our understanding by introducing the possibility of a dynamic edge, an interaction of chaotic activity that continually reshapes what we perceive as the boundary of the cosmos. This suggests a universe that is not only ever expanding but also full of surprises at every point, including its edges, inviting deeper exploration into its true nature. Quantum computing represents a significant advancement in technology that could change how we explore the universe. At its core, a quantum computer harnesses the principles of quantum mechanics, which govern the behavior of extremely small particles like atoms and photons. Unlike traditional computers that use bits as the smallest unit of data, quantum computers use qubits. Qubits can exist in multiple states at once, allowing them to process vast amounts of information simultaneously. This unique capability allows quantum computers to tackle complex calculations that are currently beyond the reach of even the most powerful classical computers. For instance, when scientists attempt to simulate the fundamental forces that govern the universe, such as gravity and electromagnetism, the calculations are so intricate that they can take an impractically long time to solve. A quantum computer could dramatically reduce this time, enabling researchers to understand the behaviors of particles and forces with far greater accuracy. Additionally, quantum computing has the potential to improve data analysis from astronomical observations. As telescopes and sensors gather massive quantities of data about distant galaxies, black holes, and cosmic structures, analyzing this information is a daunting task. Quantum computing could help identify patterns and connections in datasets more efficiently, leading to new discoveries about the universe and its origins. Moreover, it could unlock advancements in materials science and help develop better technologies for space exploration. For example, discovering new materials that can withstand the extreme conditions of deep space could pave the way for more robust spacecraft or better life support systems for future generations of space travelers. Quantum computing could be a key that opens up previously inaccessible doors in our quest to understand the universe. With its ability to handle vast amounts of data and perform complex calculations swiftly, it may soon allow us to explore the deepest mysteries of space, pushing the boundaries of what we know and bringing us closer to understanding the cosmos in ways we have only begun to imagine. The uncertainty principle is a foundational concept in quantum mechanics that tells us there are inherent limits to how precisely we can know certain pairs of properties about a particle, such as its position and momentum. Imagine trying to capture a fleeting moment perfectly, a snapshot in time. The more precisely you focus on one aspect, like where the object is located, the less clarity you gain about how fast it's moving or in what direction. This principle illustrates that at a fundamental level, our understanding of the universe is shaped by these limits of precision. When it comes to speculation about the boundaries of the universe, the uncertainty principle invites intriguing questions. If we consider particles and their interactions as the building blocks of everything in existence, the uncertainties in their properties could suggest that the boundaries of the universe themselves are not definite. Instead of having a strict edge, the universe might be more like a foggy horizon, with regions where typical rules of space and time break down. As we think about the universe's vast expanse, the uncertainty principle helps inspire theories that challenge our traditional views of boundaries. It leads scientists to ponder whether the universe has some sort of limit and where that might be, or if it somehow feeds into the idea of an ever-expanding cosmos, where boundaries are always shifting and evolving. This principle reminds us that the more we explore and learn about the fabric of reality, the more we realize that some questions may never have clear answers, and boundaries may be just as uncertain as the particles that compose everything around us. Our understanding of light has dramatically evolved, becoming a key tool in uncovering the universe's mysteries, especially at its fringes. Initially, light was thought to be a simple form of illumination. However, as scientists delved deeper, they discovered light is part of a broader spectrum, including not just what we see, but also types we cannot directly perceive, like infrared and ultraviolet. As technology progressed, telescopes began capturing light from distant stars and galaxies. This light serves as a cosmic messenger, carrying information about the objects it reaches us from. By studying the light emitted or absorbed by these celestial bodies, we learn about their composition, temperature, distance, and even motion. The colors in the spectrum reveal fundamental properties. For instance, a redshift indicates that a galaxy is moving away from us, a discovery that supports the idea that the universe is expanding. Furthermore, variations in light help us understand phenomena like black holes. When light encounters a black hole, it behaves unpredictably. Some gets absorbed while some is bent, creating a shadow-like region. These effects give us clues about the extreme gravity and structure of black holes, pushing the boundaries of our knowledge about how they function. The study of light even extends to understanding the cosmic microwave background, the faint glow left over from the Big Bang. Analyzing this light allows scientists to investigate the early universe, revealing insights into its age and evolution. Each discovery linked to light enhances our comprehension of the universe's edge, highlighting that the secrets of the cosmos often come to us through this fascinating phenomenon. Each step in our understanding of light has woven a richer narrative about the universe, connecting human curiosity with the vast, mysterious sky above. The farthest light ever observed by astronomers comes from a galaxy called GNZ 11. This galaxy is located at such a great distance that the light we see today began its journey over 13 billion years ago. This means we are looking back in time to an era when the universe was very young, just a few 100 million years after the Big Bang. Observing this ancient light gives us critical clues about the early universe and its development. When scientists study this light, they unveil the conditions that existed during that formative period. It provides insights into how galaxies formed and evolved over billions of years. Additionally, the distance from which this light originates gives us a glimpse into the vastness of the universe, stretching far beyond our own galaxy. As for the universe's boundary, it is essential to note that the universe continues to expand, and there isn't a definitive edge or limit in the traditional sense. Instead, the observable universe is defined by the farthest light we can detect, which sets the horizon of our observations. Beyond this limit, there may be more universe yet to explore, but it remains out of reach because light from those areas hasn't had time to reach us. Thus, studying these distant galaxies not only enriches our understanding of cosmic history, but also hints at the enduring mystery of what lies beyond our observable limits. Redshift and blueshift are fascinating phenomena that provide vital clues about the universe and its expansion. Imagine standing on a busy street as cars go past. When a car approaches, the sound of its horn seems higher in pitch, and as it drives away, the sound becomes lower. This change in pitch is similar to what we observe with light in the universe. When astronomers observe distant galaxies, they notice that light from those moving away from us appears shifted toward longer wavelengths, a phenomenon known as redshift. This is like shifting from the blue end of the light spectrum to the red. This redshift indicates that those galaxies are moving away, suggesting that the universe itself is expanding. The more distant the galaxy, the greater the redshift, which means it is moving away more quickly. This relationship helps scientists understand the overall rate of expansion of the universe, providing insight into its size and shape. On the other hand, blueshift occurs when an object approaches us. The light from an object moving toward us shifts to shorter wavelengths, resembling a movement from red to blue on the spectrum. While most galaxies are redshifted due to the universe's expansion, there are exceptions where nearby galaxies are blueshifted, indicating they are moving closer to us. This is primarily seen in galaxies like Andromeda, which is headed toward our own Milky Way. Together, redshift and blueshift reveal how celestial objects are organized within the vastness of space. By studying these shifts, astronomers can estimate the distances of galaxies, decode their velocities, and piece together the dynamics of the universe. Although the universe may seem limitless, understanding these phenomena brings us closer to understanding its boundaries and the nature of the cosmos itself. Studying ancient starlight is like peering back in time to gather secrets of the universe's history. Light from distant stars takes a long time to reach us, often millions or even billions of years, which means when we observe them, we are seeing them as they were in the past. This starlight carries information about the conditions of the universe at the time it was emitted, providing clues about its expansion and development. When we analyze the light from these ancient stars, we can observe how it has stretched over time due to the expansion of the universe. This phenomenon, known as redshift, indicates that the universe is not static. Instead, it is growing larger. By measuring this redshift, astronomers can infer how quickly the universe has been expanding and potentially how it might continue to do so in the future. Furthermore, ancient starlight allows us to explore the cosmic microwave background radiation, which is the faint glow left over from the Big Bang. This radiation serves as a snapshot of the early universe, giving us insights into its initial conditions and the formation of structures such as galaxies and clusters. Studying these ancient sources can ultimately lead us to understand the boundaries of the universe itself. By piecing together the history of cosmic events, we can propose theories about the universe's shape, composition, and fate. Thus, ancient starlight serves as a powerful tool that sheds light on the far reaches of space and time, illuminating our understanding of the cosmic frontier. The speed of light serves as a fundamental barrier in our understanding of the universe. Think of light as the fastest traveler in space, moving at an incredibly high pace. This speed sets a limit on how quickly information or matter can travel, effectively shaping our perception of distance and time. When we observe distant stars and galaxies, we are not seeing them as they are right now, but as they were when their light departed. For example, if a star is very far away, the light we see today actually started its journey many years ago. Consequently, the farther we look into the universe, the further back in time we are viewing. This is why light acts as a cosmic time machine, allowing us to glimpse the history of the universe. Moreover, this speed limits our ability to interact with distant parts of the cosmos. If something were to occur in a galaxy billions of light years away, we would receive that information only after many years have passed. This creates a fundamental challenge in our exploration and understanding of the universe. As we push the boundaries of space exploration, concepts like the speed of light remind us of how vast and complex the cosmos truly is, and how close we remain to the beginnings of time itself. The speed of light is not just a number, it represents the very structure of the universe. It governs the flow of time and shapes the fabric of space, guiding our quest for knowledge, while also constantly reminding us of the vast distances and the mysteries yet to be uncovered. At the edge of the universe, the concept of time can be quite different than what we experience here on Earth. To understand this, we first need to consider how space and time are linked. On Earth, time moves at a steady and familiar pace. We mark it with clocks, measuring hours and minutes as constants in our daily lives. However, as we approach the furthest reaches of the universe, things change dramatically. The expansion of the universe itself means that distant galaxies are moving away from us. This movement affects how time is perceived due to a phenomenon called redshift. As light from these distant galaxies travels through space, it stretches, causing it to shift toward longer wavelengths. This is not just a visual effect, it indicates that time, as measured from Earth, appears to slow down for observers in those distant locations. Additionally, in regions of strong gravitational fields, like those near massive objects or possibly even hypothetical edges of the universe, time could behave differently as well. In such areas, time might pass more slowly compared to our steady pace on Earth. This means that someone standing at the edge of the universe could experience time quite differently than we do in our daily lives, making moments feel stretched or even elongated. Essentially, while we live in a relatively uniform experience of time, the vastness of the cosmos introduces complexities that create varied experiences of time based on location and the effects of gravity and speed. Time is not merely a ticking clock, but a dynamic product of the universe itself, influenced by the fabric of space around us. Time dilation plays a crucial role in our understanding of the universe's boundary, particularly in how it interacts with the concepts of space and time. Imagine you are traveling close to the speed of light, a remarkable speed that challenges our intuition about motion and time. As you race forward, time begins to stretch and slow down for you compared to someone who remains still. This phenomenon shows how the experience of time can change dramatically based on speed and gravity. Now think about the edge of the universe. While there isn't a physical boundary in the traditional sense, the observable universe is limited by the farthest distances light has traveled since the Big Bang. As we look further out into space, we are also looking back in time. The light from distant objects has taken billions of years to reach us. As we explore these distant galaxies, we realize they may be moving away from us at extraordinary speeds, influenced by the expansion of space itself. At that edge, where galaxies recede at incredible velocities, the effects of time dilation become even more apparent. An observer on a distant galaxy moving rapidly away from us might perceive time flowing at a different rate than we experience on Earth. This means that as we consider the universe's limits, we must keep in mind that time is not a constant. It's a flexible dimension shaped by motion and gravity. In this way, time dilation can alter our perspective of the universe's boundary. It suggests that while we can observe and measure distances, the nature of time itself can complicate our understanding of those vast reaches. The interplay between time and space continues to challenge us, driving the quest for deeper insights into the very fabric of the cosmos. Cosmic timelines provide a framework for understanding the history and evolution of the universe, and they suggest intriguing possibilities about life beyond what we currently know. Imagine viewing the universe as a vast tapestry, where each thread represents significant events, from the Big Bang to the formation of stars, planets, and galaxies. By studying these timelines, we can glean insights into processes that might foster life. For instance, cosmic timelines can highlight periods where conditions may have been favorable for life, such as when stars like our Sun formed, creating necessary elements for planets. This understanding encourages us to look beyond our galaxy, considering other planets forming under similar conditions elsewhere in the universe. Moreover, cosmic events like supernovae can leave traces in the timeline, illustrating how elements essential for life are distributed across space. Such studies lead scientists to consider solar systems similar to ours. Each point on the timeline opens up questions. When did the first planets form? How did those planets evolve? Were any of them hospitable to life? Additionally, timelines also inform us about the potential age of other celestial bodies and their capacities to support life. They suggest that the universe is full of diversity. While our own solar system has only developed a specific kind of life over billions of years, the timelines hint that numerous stars could have hosted life forms across different epochs. The fluctuations in cosmic conditions and the development of galaxies suggest that life could emerge under varied circumstances. The search continues through advanced telescopes and space missions, examining planets that orbit distant stars within their habitable zones. By looking at these timelines, we expand our understanding and refine our search for life beyond our known surroundings, all while considering the endless variety that the universe might hold. The universe is approximately 14 billion years old, which provides a timeline for everything we observe around us. However, when we think about the edge of the universe, it's essential to clarify that the universe does not have a traditional edge like a flat piece of paper. Instead, the age plays a crucial role in how we understand the universe's shape and structure. As the universe expands, everything within it moves away from everything else. This expansion means that light from distant galaxies has taken billions of years to reach us, allowing us to see them as they were in the past. The furthest points we can observe today are often referred to as the observable universe. Imagine this as a vast sphere of light, where the surface represents the limit of what we can see. It does not circumscribe an actual boundary, but rather indicates how far light has traveled since the beginning of time. Beyond that observable region, the universe continues. We simply cannot see what lies beyond because the light from those areas hasn't reached us yet, not due to an edge, but rather because of the finite speed of light. Additionally, cosmic expansion suggests that areas outside our observable universe may be receding from us so rapidly that their light will never reach us. The universe's age helps define the limits of what we can observe, but it does not imply a physical edge. Instead, the universe stretches infinitely beyond our sight, encouraging us to explore further, even as we grapple with the vastness of space and time. Time is a fundamental element in our understanding of the universe, influencing everything from cosmic events to the very nature of space itself. As we explore theories about the universe's limits, time serves as both a measurement and a concept that directly interacts with the fabric of reality. At its core, time helps us comprehend how events unfold in the cosmos. It allows scientists to sequence moments, from the birth of stars to the collision of galaxies, providing a timeline of cosmic history. This timeline gives context to the universe's expansion, suggesting that during its early moments, everything was concentrated in a tiny, extremely hot state before expanding rapidly. This expansion is ongoing, and time tells us how far along we are in this process. In addition to its role as an organizer of events, time also impacts our understanding of gravity and the structure of space. According to Einstein's theory of relativity, time is intertwined with space in a four-dimensional continuum known as spacetime. As mass increases, such as when we observe a massive object like a planet or black hole, the influence on time becomes evident. This implies that time can flow differently depending on gravitational fields, which complicates the notion of universal limits. When we consider the edge of the universe, known as the observable universe, time informs us about how far we can see based on how long light from distant galaxies has taken to reach us. Furthermore, contemplating the limits of the universe leads to questions about whether time itself has a beginning or an end. Some theories propose that time started with the Big Bang, while others wonder if it could stretch infinitely into the future or loop back on itself in a cyclical manner. Each idea alters our perception of the universe's boundaries, directly tying time to our understanding of existence and the cosmos. Ultimately, time shapes theories about the universe's limits by helping us piece together a narrative that intertwines events, structures, and the fundamental laws of physics. It influences how we grasp the vastness of space and guides our quest to uncover what lies beyond. As we explore the outer reaches of our universe, the potential for dramatic celestial collisions looms large. Picture the universe's edge as a chaotic region where galaxies are often moving at incredible speeds, influenced by the expansion of the cosmos. In these distant realms, galaxies can collide, merging in a spectacular dance. Such encounters can lead to the formation of new stars, as gas and dust are compressed together, reigniting the fire of stellar birth. Another fascinating possibility involves the collision of neutron stars. These remnants of supernova explosions are incredibly dense, with masses greater than that of the Sun, all crushed into a sphere no larger than a city. When two neutron stars spiral toward each other, they create a cataclysmic event. The result can be a moment of brilliance, a gravitational wave that ripples through space, and possibly a kilonova, an explosion that outshines entire galaxies, dispersing heavy elements into the universe. Even more dramatic could be encounters with black holes. As cosmic giants, black holes extract everything around them into their gravitational pull. If two black holes were to collide, it would create a powerful force releasing energy equivalent to countless suns. This event would be a major breakthrough in our understanding of gravity and spacetime, as it would produce strong gravitational waves detectable across vast distances. In these scenarios at the universe's edge, collisions serve as both destructive and creative forces. They rearrange the cosmic landscape and give birth to new structures, leading to an ever-evolving universe full of surprises. Each collision tells a story, revealing the dynamic nature of space and time at the very boundaries of our understanding. Cosmic conflict, such as the ongoing interactions between galaxies, helps shape our understanding of the universe's boundaries. Imagine the universe as a vast expanse filled with countless galaxies, some of which are moving towards each other due to their gravitational attractions. When these galaxies collide, they create spectacular events that lead to the merging of stars and the formation of new celestial bodies. These moments of cosmic turmoil can offer clues about the limits of our universe. For instance, analyzing how galaxies interact provides insight into the distribution of matter and energy across vast distances, which helps scientists establish whether the universe is infinite or has an edge. If galaxies are constantly moving apart, it could suggest the universe is expanding endlessly. However, if collisions and mergers happen frequently, it may indicate a more complex structure with gravitational boundaries. Additionally, the data from these cosmic battles allows us to explore dark matter and dark energy. These mysterious components play critical roles in the dynamics of galaxies during such conflicts. Understanding how they influence these encounters informs our models of the universe's expansion and its ultimate fate, including possibilities like collapse or continued expansion. The chaotic yet mesmerizing nature of cosmic conflict acts as a lens through which we examine the very fabric of the universe. By actively studying these interactions, scientists gather evidence to refine theories about the universe's shape and boundary, pushing us closer to unraveling the mysteries of our existence within this grand cosmic stage. Dark matter is a mysterious substance, making up a significant part of the universe's total mass, but it does not emit or interact with light the way ordinary matter does. This unseeable material affects the structure and evolution of the cosmos, shaping galaxies and their formation. When we talk about dark matter clashes, we refer to the interactions between large clumps of dark matter, which can have a profound impact on the universe beyond what we currently observe. Imagine the universe as a vast ocean. Most of what we see, like stars and galaxies, are akin to visible islands dotting the surface. Dark matter forms an expansive, invisible landscape beneath the ocean's surface, providing the scaffolding that holds these islands together. When clumps of dark matter converge, their gravitational tug-of-war can lead to significant restructuring. This interaction might create higher density regions that could eventually attract more normal matter, potentially igniting the formation of new stars and galaxies. Beyond the current boundaries of the observable universe, the influence of these clashes becomes even more intriguing. If dark matter can pull matter from the expanding universe into its folds, it may lead to the creation of structures that we have yet to see. As the universe continues to expand, the effects of dark matter may help determine the fate of galaxies, influencing whether they drift farther apart or even collide. Additionally, as dark matter clashes unfold, they might generate gravitational waves, ripples in spacetime created by massive movements in the universe. These waves could carry information across enormous distances, offering insights into events happening far beyond what we can currently observe. Thus, the hidden interactions of dark matter, while virtually invisible to our current methods of observation, play a crucial role in shaping the universe's future landscape, hinting at new realms and possibilities that await discovery. Cosmic ripples, known scientifically as gravitational waves, serve as messengers from the very fabric of the universe. Imagine the surface of a still pond. When you throw a stone into it, waves spread out, creating ripples that travel outward. In space, these ripples occur when massive objects like black holes or neutron stars collide or move rapidly. Their immense gravitational forces create disturbances that shake the very structure of space-time itself. At the universe's edge, these ripples tell us stories about violent cosmic events. For instance, when two black holes spiral towards each other, they create waves that carry information about their mass and energy. By detecting these gravitational waves on Earth, scientists can piece together the details of these cosmic events, which are often hidden from view by light alone. This ability to hear the universe adds a new dimension to our understanding of the cosmos. These cosmic ripples also provide clues about the birth of the universe and its expansion. Just as the sound of thunder follows a lightning strike, the ripples in gravitational waves give us insight into the events that shaped our existence. They help us explore the dynamics of the most extreme environments, enhancing our knowledge of the fundamental laws that govern the cosmos. Through this sound of the universe, we come to grasp the dramatic and energetic processes occurring at the edge of existence, deepening our comprehension of the universe itself. Gravitational waves are ripples in the fabric of space-time, created by some of the most violent and energetic events in the universe, like colliding black holes or neutron stars. When these colossal bodies interact, they send waves through space-time much like ripples spread across a pond when a stone is thrown in. By detecting these waves, scientists can gain insights into events that are often invisible to traditional telescopes. Imagine trying to understand a conflict at the edge of the universe. These violent cosmic events are like battles where massive forces clash, but the light from these events may not always reach us, either because they're too distant or because they occur in areas shrouded by dust and gas. Gravitational waves, however, pierce through this obscurity. They carry information across vast distances, revealing the dynamics of these far-off conflicts in ways that light alone cannot. Researchers use incredibly sensitive detectors on Earth to capture these waves. When a gravitational wave passes through, it stretches and compresses space itself, leading to tiny changes in distance that can be measured with great precision. Analyzing these measurements, scientists can infer details about the masses, spins, and other properties of the colliding objects, providing a clearer picture of the events that unfolded. Moreover, these signals can help us understand the nature of gravity itself and how it interacts with matter under extreme conditions. This knowledge bridges gaps in our understanding of both astrophysics and fundamental physics, offering clues to the universe's most profound mysteries. Through gravitational waves, we are not just hearing echoes from the violent edge of the universe, we are being invited to explore the origins and behaviors of cosmic phenomena that shape everything we see. The constants of physics are fundamental values that dictate how the universe behaves. They are like the rules of a game. Understanding them helps physicists create theories about everything from the smallest atoms to the vastness of space. For example, one of these constants is the speed of light. It sets a limit on how quickly information and matter can travel, influencing everything from our understanding of time to how far we can see in the universe. When it comes to the universe's boundaries, these constants play a crucial role. They help define the structure of space-time, which is the fabric that joins space and time together. If one of these constants were different, even slightly, the nature of the universe could change dramatically. It could affect whether galaxies form, how stars burn, or even whether life as we understand it could exist. In theories about the universe's edge, such as the concept of an expanding universe, constants determine how fast the universe expands. They also impact the ultimate fate of the universe, whether it might continue to spread infinitely or eventually collapse back on itself. As scientists explore these boundaries, they depend on understanding how these constants influence gravitational forces, electromagnetic interactions, and more. Each piece of knowledge aligns to form a bigger picture, guiding us in our quest to comprehend the vastness of existence and the mysteries that lie beyond what we can see. The fine structure constant is a fundamental number in physics that helps determine the strength of electromagnetic interactions, which are vital for understanding how particles interact and form the building blocks of matter. Imagine it as a key that sets the scale for various physical processes. This constant plays a crucial role in governing the behavior of atoms, affecting properties such as the size of atoms and the energy levels of their electrons. When we consider the universe's edge, the very boundary of our understanding of the cosmos, the fine structure constant becomes significant in a few ways. It influences the formation of stars and galaxies by dictating how atoms bond and how light interacts with matter. These processes, in turn, shape the structure of the universe we observe. Additionally, researchers explore whether this constant holds the same value throughout the universe and whether it behaves consistently across vast distances. Any variation could suggest changes in fundamental laws of nature or points to areas of the universe that function differently than our local environment. Understanding the fine structure constant not only gives us insights into atomic behavior, but also serves as a gateway to unraveling deeper mysteries about the universe's composition, its expansion, and the true nature of its boundaries. This exploration might ultimately lead us to understand whether there might be dimensions or realms that we have yet to discover. Imagine the laws of physics as the rules of a game. These rules are defined by constants, which are specific values that determine how the universe behaves. If you were to change these constants, like adjusting the rules of a game, you would shift what is possible within the universe. For instance, consider the gravitational constant. It governs how objects with mass attract one another. If this constant were larger, gravitational forces would be stronger. This change could lead to galaxies forming much more densely, potentially changing the kinds of stars that could exist and even altering the life cycles of those stars. Similarly, the speed of light is another vital constant that influences everything from the creation of elements in stars to how we perceive the universe itself. Imagine if the speed of light was slower. Information would travel differently, affecting everything from the formation of structures in space to the very nature of time. The result might be a universe where distances feel greater and interactions take longer, fundamentally changing how matter and energy interact. Changing the constants might also redefine what is capable of existing. For instance, if the electromagnetic force were significantly weaker, atoms might not hold together effectively, leading to a universe devoid of the structures necessary for stars and planets. This scenario offers a captivating thought, a universe where life, as we understand it, could not exist. Altering these fundamental constants could lead to a universe that diverges drastically from our own, with new forms of matter, energy interactions, and even entirely different laws of physics shaping its destiny. This invites us to rethink not just the limits of our universe, but the very nature of existence itself. Constants like Planck's constant are fundamental building blocks in our understanding of the universe. Planck's constant is a very small number that plays a crucial role in the world of quantum mechanics, which describes the behavior of particles at the tiniest scales. To grasp its importance, think of it as a bridge between the world of the very small and the vastness of the cosmos. When scientists study the universe's boundaries, they often explore how matter and energy behave under extreme conditions. At these boundaries, such as black holes or the very early moments of the universe, quantum effects become significant. Planck's constant helps to establish the scales at which these quantum effects dominate. For instance, it defines how energy levels of particles behave in tiny increments rather than continuous amounts, influencing the way we understand radiation and energy emission from stars and galaxies. Furthermore, Planck's constant sets the scale for what is known as the Planck length, the smallest measurement of space with physical meaning. This boundary suggests a limit to our current understanding, hinting that below this scale, traditional physics may no longer apply. As researchers delve into cosmic mysteries like the nature of black holes or the conditions just after the Big Bang, they rely on this constant to make fundamental predictions about what might occur in spaces where our current theories begin to falter. Constants like Planck's are instrumental because they provide a framework for exploring and explaining the behaviors of matter and energy at the smallest scales, which in turn helps us probe the very boundaries of the universe itself. They not only influence theoretical models, but also guide experimental investigations, shaping our quest to understand the cosmos. Physical constants are the universal rules that govern how everything functions, acting like the foundation of a vast house built of knowledge. These constants, such as the speed at which light travels, the strength of gravity, and the electric charge of particles, remain the same regardless of where or when you are in the universe. They provide a stable framework that scientists rely on when probing the mysteries surrounding the edges of the universe. Imagine the speed of light as a limit, not just for how fast light travels, but as the maximum speed at which information and matter can move. This constant allows scientists to calculate distances across space and understand how light from distant galaxies tells us about their properties and behaviors. Without this consistent measure, it would be nearly impossible to grasp the immense scales involved when studying the universe. Gravity, another essential constant, governs the interaction between mass and space. It keeps planets in orbit around stars, shapes galaxies, and influences the motion of celestial bodies. Understanding how strong this force is allows researchers to infer the structure of the universe. For instance, they can calculate the gravitational pull of far-off objects, helping to identify what lies beyond our observable horizon. Furthermore, these constants play a crucial role in the laws of physics. They help formulate theories that describe the behavior of particles at the tiniest scales, influencing how we interpret the fundamental forces acting in the universe. With these theoretical tools, scientists can make predictions about cosmic phenomena, from the birth and evolution of stars to the mysterious nature of dark matter and dark energy. Thus, physical constants not only provide a bedrock for scientific inquiry, but also enable us to explore the universe's edges with confidence. They are the constants of nature that allow our understanding to grow, guiding our quest to unlock the secrets of what lies beyond our observable world. The life cycle of a star is a fascinating journey that begins with a cloud of gas and dust in space, known as a nebula. Over time, gravity pulls this material together, causing it to collapse into a dense region. As the material gathers and compresses, temperatures rise dramatically, and eventually nuclear fusion ignites in the core. This marks the birth of a new star. During most of its life, a star fuses hydrogen into helium, releasing massive amounts of energy. This energy creates pressure that balances the gravitational pull trying to collapse the star. This main sequence phase can last billions of years, depending on the star's mass. For massive stars, this life cycle is relatively short-lived, while smaller stars, like our Sun, enjoy a lengthy existence. When a star exhausts its hydrogen fuel, it enters the next stages of its life cycle. For larger stars, this means expanding into a red giant, and in some cases exploding as a supernova, leaving behind a neutron star or a black hole. Smaller stars transition into red giants as well, but ultimately shed their outer layers, forming a beautiful planetary nebula, while their cores become white dwarfs that will cool and fade over time. The significance of stars at the universe's edge cannot be overstated. Newly formed stars contribute to the expansion of galaxies, creating heavy elements that enrich the surrounding space. When they end their lives, especially in supernova explosions, they spread these elements across the universe, allowing for the formation of new stars, planets, and even life. This process highlights the interconnectedness of celestial bodies and shows how the death of one star can lead to the birth of another, helping to create a dynamic and ever-evolving cosmos. The life cycles of stars are fundamental to understanding not just our universe's structure, but also the origins of the very elements needed for life itself. The birth of stars is closely tied to the dynamics of the universe, particularly its expansion. To understand this relationship, imagine the universe as a vast balloon. When this balloon is inflated, the surface stretches, and so do the distances between the dots marked on it. Similarly, our universe is expanding, causing galaxies to move away from one another. In the vastness of space, gas, and dust, the building blocks of stars are scattered throughout. When regions of this gas accumulate enough mass due to their own gravity, they can start to collapse inward. This collapsed material heats up, eventually igniting nuclear fusion at the center, which marks the birth of a new star. As the universe continues to expand, the conditions for star formation can shift. More distant areas of the universe may become less accessible due to the expansion, affecting the availability of gas and the potential for new star births. When galaxies collide or come close to one another, this interaction can compress gas, leading to bursts of star formation. Thus, galaxies that are moving apart can also experience moments where new stars are born, showcasing a beautiful yet complex relationship between the universe's expansion and stellar life cycles. This continuous cycle of birth, evolution, and eventual death of stars adds to the overall fabric of the universe while reflecting the ongoing changes from its ever-expanding boundary. Each new star contributes to the universe's diversity and highlights the dynamic nature of cosmic evolution amidst the vast stretches of space. The deaths of stars are not just dramatic events, they play a crucial role in shaping the universe itself. When a massive star exhausts its nuclear fuel, it goes out with a spectacular explosion called a supernova. This explosion spreads elements, such as carbon, oxygen, and iron across space, enriching the surrounding material and creating new building blocks for future stars, planets, and even life. This cycle of birth and death in the cosmic realm suggests that the universe is constantly evolving. Now, when we think about what exists beyond the observable universe, we enter a sphere of speculation. The universe we can see is limited. It stretches for a great distance, beyond which light from other galaxies has not yet had the time to reach us. However, just as death leads to rebirth in stellar life cycles, one can imagine that regions beyond our sight are likely in various stages of evolution. Perhaps they are home to stars in their infancy, in the process of forming from clouds of gas and dust, or maybe they host dying stars that will soon explode. These unseen regions could also challenge our understanding of cosmic structure. For instance, if the universe is expanding as we observe, then the regions beyond our eyesight could be filled with galaxies moving away from us so quickly that their light can't catch up. This could imply the presence of vast, uncharted realms teeming with unknown properties and phenomena. The effects of star deaths in our known universe, therefore, may mirror a larger universal process that is both complex and interconnected. While the stars' deaths are a vital part of our cosmic landscape, they hint at the possibility of uncharted territories beyond our visible horizon, filled with rich history and potential for new beginnings. The cycle of stellar life serves as a reminder that the universe is not static. Rather, it is a dynamic, ever-changing expanse full of mysteries waiting to be revealed. Supermassive black holes, which are billions of times heavier than our Sun, reside at the centers of most galaxies, including our Milky Way. However, their presence at the farthest edges of the universe poses intriguing questions for astrophysicists. These massive cosmic entities seem to have formed earlier than current theories predict, which suggests that the processes driving their growth could be more complex than we imagined. Where traditional models of galaxy formation often assume a gradual buildup, where stars form first and gradually merge to create larger black holes, observations of these supermassive black holes create a puzzle. If they existed shortly after the Big Bang, they might indicate that black holes can grow rapidly, possibly through mechanisms like the collapse of massive gas clouds or the merging of smaller black holes. This sudden emergence raises doubts about our understanding of how galaxies themselves evolve. Furthermore, the growth of supermassive black holes at such extreme distances suggests that they may influence the surrounding cosmic environment in unexpected ways. Their powerful gravitational fields could affect star formation rates and the behavior of galaxies nearby. This could mean that our models need to incorporate the effects of black holes not just at their cores, but throughout the cosmos, shifting our view of how the universe develops over billions of years. Understanding these distant black holes requires innovative approaches and tools. Researchers might have to refine current theories to include the rapid formation and growth of these giants. As we gather more data from telescopes observing the universe in various wavelengths, we will get closer to unraveling the mysteries of these extraordinary objects and redefining our models of the cosmos. In this way, supermassive black holes at the universe's edge not only challenge existing beliefs, but also propel the field of astrophysics toward new horizons of discovery. Pulsars, as well as other stellar remnants, play a crucial role in how we perceive the limits of our universe. A pulsar is a highly magnetized, rotating neutron star that emits beams of radiation, which sweep across space like a lighthouse. When this radiation is aimed at Earth, we observe regular pulses, which can help us understand the extreme conditions of dense matter and the forces at play within these remnants. Stellar remnants, including white dwarfs, neutron stars, and black holes, offer a glimpse into the life cycle of stars and the processes that govern their evolution. Each type of these remnants has unique properties and behaviors that challenge our understanding of physics, particularly in extreme environments. For instance, the strong gravitational fields around black holes test the limits of our theories about gravity and space-time. Studying pulsars helps scientists map cosmic distances and determine the structure of the galaxy. The way these stars emit regular beats allows scientists to use them as cosmic clocks, confirming or refining theories regarding the expansion of the universe. The interaction of pulsars with other materials in their environment can also reveal the presence of unfathomable quantities of energy and matter, further leading to discussions about the universe's edge and what lies beyond it. In addition, observing how stars evolve into these remnants gives insights into the conditions in the early universe, illuminating the mechanisms that led to the creation of galaxies and larger cosmic structures. Therefore, pulsars and stellar remnants do more than just exist. They serve as vital tools for scientists, offering pieces of the puzzle regarding the universe's boundary and the fundamental laws governing it. By studying these celestial objects, we not only learn about their unique characteristics but also gain a deeper appreciation for the cosmic tapestry as a whole and the mysteries that still await discovery. Throughout history, various cultures have imagined the edge of the universe in distinct and fascinating ways. These depictions often reflect humanity's desire to understand the unknown and our relationship with the cosmos. In ancient Mesopotamia, the universe was envisioned as a flat disk surrounded by a vast, chaotic sea. Above this disk, the sky was considered a solid dome where the stars were embedded. The edge of the universe was thus seen as a boundary between the familiar land and the mysterious waters that held the cosmos together. In contrast, ancient Greek philosophers introduced more abstract ideas. They spoke of a spherical universe where celestial bodies moved in circles. The edge of this world was thought to be a realm of chaos, beyond which lay nothingness, a void that represented the unknown. This concept laid the groundwork for later philosophical and scientific thought, shaping how we view space today. In Native American traditions, many tribes have a rich tapestry of myths describing the universe. Some picture the cosmos as a series of layers or realms, where the edge is a sacred space inhabited by spirits. These stories emphasize a harmonious connection between the earth, the sky, and everything in between, suggesting that the edge of the universe is not so much a limit as it is a gateway to spiritual realms. The ancient Chinese had their own beliefs, often visualizing the universe in a yin and yang balance, where the edge was not seen as a hard boundary, but as a dynamic interplay of forces. This understanding reflects a sense of continuity and the idea that the universe is ever-changing, flowing back into itself like a circle. As civilizations evolved, so did their concepts of the universe. The edge has been depicted as both terrifying and inspiring, filled with cosmic monsters or celestial gardens. These narratives reveal that no matter the culture, the quest to understand the universe remains a fundamental part of the human experience, bridging the gap between wonder and knowledge. Each myth carries echoes of how our ancestors grappled with the mysteries beyond the stars, seeking to explain what lies at the edge of existence. Throughout history, various cultures have proposed intriguing beliefs about what lies beyond our universe. These ideas highlight the human desire to understand not just the physical realm we inhabit, but also the mysteries that extend beyond it. Many ancient civilizations viewed the universe as a cosmic body that was often intertwined with their religious beliefs. For instance, in some indigenous cultures, the stars are seen as ancestors watching over humanity, linking the cosmic to the earthly in a spiritual way. In Eastern philosophies, particularly within Hinduism and Buddhism, there is the concept of multiple realms of existence. This includes ideas of cycles of creation and destruction, suggesting that beyond our visible universe lies an infinite continuum of realities, where souls journey through various lifetimes and dimensions. Conversely, in Western traditions, particularly during the Age of Exploration and the Scientific Revolution, there was speculation about the universe being bounded or infinite. Some philosophers imagined a vast expanse containing either nothingness or perhaps other worlds, similar to our own, with beings who might inhabit them. In a more modern context, scientific theorists have suggested concepts like the multiverse, where our universe is just one of countless others, each with its unique laws and variations. This idea challenges previous beliefs by framing existence itself as part of a much larger tapestry, where what lies beyond might be an endless array of universes, each with different realities. These cultural beliefs reveal a timeless quest for understanding. They intertwine imagination with the pursuit of knowledge, offering unique perspectives on the great unknown that beckons just beyond the edges of our own universe. Ancient civilizations laid the groundwork for our modern understanding of the universe, shaping the way we explore it today. Many cultures, such as the Egyptians, Babylonians, and Greeks, looked to the stars with wonder. They devised early astronomical systems, mapping the night sky and creating calendars based on celestial events. These observations were not merely academic, they were deeply intertwined with agriculture, navigation, and religious practices. For instance, the Babylonians were among the first to use a systematic approach to observe and record the movements of celestial bodies. They noted the cycles of planets, contributing to our understanding of predictable astronomical events. Additionally, the Greeks brought forth a philosophical approach, posing questions about the nature of the cosmos and humanity's place within it. Figures like Aristotle proposed models of the universe, while later thinkers like Copernicus laid the foundation for a heliocentric view, which changed our perception of Earth's position in the cosmos. As we developed tools and technology, from telescopes to space probes, the spirit of curiosity ignited by ancient astronomers fueled our quest to explore further. The modern study of the universe's edge, including concepts like dark matter and dark energy, can trace its roots back to these early thinkers. Their questions and observations inspire today's scientists to push boundaries and seek answers about the vast unknown beyond our planet. The influence of ancient civilizations on modern scientific exploration is profound. They equipped us with fundamental knowledge and a sense of wonder that continues to drive our bold quests into the unknown expanses of the universe. Throughout history, various myths and legends have emerged, attempting to explain the vast and mysterious cosmos that surrounds us. One common theme across many cultures is the concept of a cosmic ocean or void. In these stories, the universe is depicted as a limitless expanse where celestial bodies float, often likened to islands in a grand sea. This imagery reflects humanity's fascination with the infinite and the unknown. For example, in ancient Egyptian mythology, the sky goddess Nut was often portrayed as a vast expanse draped over the earth, symbolizing the boundaries of the cosmos. The stars were seen as her body sprinkled across the night, and the sun's journey each day represented a cycle of rebirth and the eternal nature of the universe. Similarly, in many Native American traditions, the creation stories emphasize a great void or darkness before the emergence of the world. The universe is viewed as a living entity, deeply interconnected with the earth and its inhabitants. These narratives highlight a sense of wonder and respect for the cosmos, suggesting that it is both a source of life and a space of endless possibility. In Norse mythology, the cosmos is divided into 9 realms, all interconnected by the great tree Yggdrasil. This tree reaches from the depths of the underworld to the heavens, symbolizing the relationship between different realms and the vast nature of existence. It serves as a reminder of the boundaries within which life and death coexist, all within a larger, infinite universe. Each of these stories reflects humanity's quest to understand the boundaries of the cosmos, whether as a source of life, an ocean of chaos, or a vast tree connecting various worlds. They serve as a mirror of our curiosity about what lies beyond our reach, ultimately echoing the scientific pursuit to explore every corner of the universe. Cultural narratives deeply influence how we perceive and explore the limits of the universe. From ancient stories of celestial gods to modern science fiction, these narratives shape our questions and, ultimately, our understanding. They play a role in framing our curiosity, guiding what we consider possible or impossible in the cosmos. For instance, consider how different cultures envision the night sky. In some traditions, the stars are seen as the souls of ancestors watching over us, instilling a sense of connection to something greater. This fosters a curiosity about whether life exists beyond our planet and what that existence might mean. In other cultures, the view of the sky is more scientific, pushing humanity to seek answers through observation and experimentation. These varying perspectives drive different approaches to exploring the universe, whether through storytelling, mythology, or scientific inquiry. Moreover, as new discoveries are made, such as the existence of black holes or the vast distances between galaxies, culture adapts. These stories evolve, inspiring artists, writers, and scientists to push boundaries even further. Cultural narratives not only reflect our curiosity, but also ignite it, acting like a spark that flames into questions about our origins, our place in the cosmos, and the nature of existence itself. Our shared stories create a framework for understanding and questioning the unknown. They help us navigate the expansive possibilities of the universe, encouraging exploration and wonder about what lies beyond our current grasp. As we seek answers, these narratives remind us of the profound connection between imagination and scientific inquiry, showing how our cultural lens shapes the quest for knowledge in the vastness of space. Artists have long been captivated by the concept of the edge of the universe, often imagining it as a vast, mysterious boundary where everything we know comes to an end. In their representations, they frequently show the universe filled with swirling galaxies, shimmering stars, and breathtaking nebulae, creating a sense of the unknown that beckons viewers deeper into the cosmos. One common approach is to depict the universe as a glowing expanse that fades into darkness, symbolizing the limits of our understanding. They might paint a night sky transitioning from vibrant colors of red and blue into deep, dark blackness, illustrating the idea that as you venture further into space, light becomes scarce. This fading is often used to symbolize the edge of known reality, where the familiar laws of physics start to break down, or where the fabric of space and time itself may stretch and curve in ways we struggle to comprehend. Some artists also explore the concept of infinity and the cosmos beyond our perception. They may show portals or gateways leading into vibrant, chaotic realms, suggesting that what lies beyond the observable universe is not just emptiness, but possibly different dimensions, alternate realities, or even parallel universes teeming with life. These imaginative depictions challenge viewers to think about the infinite possibilities of existence and the limitations of human understanding. Additionally, artists might incorporate scientific elements into their work, using imagery inspired by actual scientific theories, such as cosmic background radiation or the structure of the universe itself. By blending science with art, they create a dialogue between the known and the unknown, inviting audiences to ponder profound questions about existence and the very nature of reality. Through their visual narratives, artists craft a captivating portrayal of the edge of the universe as a space for exploration, wonder, and reflection, compelling each of us to look up at the night sky and consider our place within it. Surrealism plays a unique and vital role in exploring cosmic boundaries through art. This movement is all about tapping into the subconscious, challenging reality, and presenting dreams and fantasies in visually striking ways. When applied to cosmic themes, surrealism allows artists to stretch the imagination beyond the limits of the known universe. By using unexpected combinations of objects and scenes, surrealist artists invite viewers to consider the unknown, whether that be distant galaxies, alien worlds, or the mysteries of space and time. The works may depict scenes where gravity seems absent, where celestial bodies interact in impossible ways, or where time flows differently. These images prompt questions about existence, reality, and what lies beyond our perception. Moreover, surrealism connects with human emotions and experiences, transforming abstract cosmic concepts into feelings of wonder, awe, and even anxiety. It serves as a bridge between science and art, portraying the intriguing hypotheses of astrophysics and avant-garde theories in ways that resonate with viewers. Thus, surrealist art doesn't just depict cosmic boundaries, it encourages deep reflection on humanity's place in the universe, our hopes, fears, and the perpetual search for understanding amidst the vast unknown. Modern artists have drawn profound inspiration from the universe's edge, translating the mysteries of space into compelling visual expressions. The concept of the universe's edge invites contemplation about what lies beyond our observable reality. Artists explore these themes of infinity and the unknown, creating works that evoke feelings of wonder and curiosity. For instance, some artists capture the vastness of space through expansive canvases filled with swirling galaxies and shimmering stars. They use colors and textures to mirror the breathtaking beauty and dynamic nature of the cosmos, inviting viewers to experience the enormity of the universe as they gaze at the artwork. These pieces often lead us to reflect on our place within this grand tapestry. Other artists delve into the more abstract aspects of cosmic themes using shapes and forms that symbolize various cosmic phenomena. They might evoke the power of black holes through dark, swirling patterns that suggest both destruction and creation, challenging viewers to question the nature of existence itself. This abstraction allows a personal interpretation of the universe's mysteries, inviting the audience to engage intellectually and emotionally. Additionally, modern technology has opened new avenues for artistic expression. With digital media, artists can simulate cosmic events, creating interactive installations that immerse viewers in a universe of their own making. Visitors might feel as if they're traveling through space, experiencing visuals that mirror astronomical discoveries and the boundary of our understanding. In all these forms, modern art becomes a bridge between science and creativity, sparking dialogue about the universe's edge. Through their works, artists encourage us to ponder questions of life, space, and the infinite possibilities that lie just beyond our world, enriching our appreciation for both art and science. Art offers a fresh lens through which we can explore scientific theories about the universe. While science relies on data, empirical evidence, and mathematical precision to describe the cosmos, art steps in to capture the emotional and conceptual essence of these ideas. Think of how a painting of a starry night or a sculpture depicting a black hole evokes feelings and sparks imaginations. Artists can visualize complex theories such as the Big Bang or quantum mechanics, transforming abstract concepts into tangible experiences. For example, a dramatic representation of space-time could help viewers grasp its complexities, showing how reality bends under the influence of massive objects. This creative interpretation invites us to ponder questions that scientific explanations may not address, such as the meaning of existence or our place in the vast universe. Furthermore, art can bridge the communication gap between scientists and the public. It makes profound scientific notions accessible and relatable, inspiring curiosity and exploration. Through storytelling, visual imagery, and emotion, art engages audiences in a dialogue about science, prompting discussions about everything from the birth of stars to the mysteries of dark matter. By marrying emotion with scientific fact, art deepens our understanding of the universe. It challenges us to look beyond numbers and data, encouraging us to embrace the wonders and mysteries of existence in a way that resonates personally. Together, science and art enrich our comprehension of the cosmos, showing us that the universe is not just a place described by theories, but also a realm filled with beauty and inspiration. Art possesses a unique ability to translate complex and abstract ideas into something that resonates on a personal and emotional level. When we think about the edge of the universe, concepts such as infinity, dark matter, or the fabric of space-time can feel overwhelming and difficult to grasp. Through various artistic expressions, these ideas can be shaped into visual narratives that spark curiosity and understanding. Imagine a painting that depicts the vastness of space, where colors blend seamlessly into one another, symbolizing the transition from light to darkness. This gradient can help the viewer contemplate the idea of the universe stretching out endlessly, inviting questions about what lies beyond the observable limits. Similarly, sculptures or installations using materials like glass or metal can mimic the idea of light curves or gravitational waves, making abstract phenomena more tangible. Artists often draw from scientific theories and data, translating them into visual languages. For example, representations of black holes, which are places in the universe where the gravitational pull is so strong that nothing can escape, can be depicted visually to convey their mysterious and consuming nature. By using swirling colors and dynamic shapes, artists can depict the swirling accretion disks that funnel matter into these cosmic giants. Beyond just visual representation, art encourages imagination. It challenges viewers to consider their place in the cosmos. By merging science with creativity, art can foster a sense of wonder and prompt people to explore these abstract concepts more deeply, fostering discussions around the nature of reality and existence itself. Thus, art serves not just as decoration, but as a bridge, connecting complex scientific ideas to the viewer's mind. It opens up avenues for engagement, allowing audiences to explore the universe's edges with both intellect and emotion, ultimately enhancing our collective understanding of the cosmos. As humanity gazes toward the unknown reaches of the universe, it opens a Pandora's box of ethical questions. First and foremost is the question of responsibility. If we attempt to explore the far corners of space, do we have an obligation to protect any potential life forms we might encounter? The prospect of disturbing alien ecosystems raises significant concerns about whether our actions might inadvertently lead to extinction or severe disruption of those systems. Then, there's the issue of resource exploitation. Our attempts to mine asteroids or other celestial bodies bring up questions about ownership and stewardship. If we extract precious materials from these places, who has the rightful claim? And how will those actions impact the balance of our own environment back on Earth? The desire for expansion must be weighed against the consequences for both our planet and any other worlds we might affect. We also need to consider the implications of scientific discovery. As we gather knowledge about the cosmos, how do we ensure that our findings are used ethically? There's the potential for technologies developed for space exploration to be misused or appropriated for harmful purposes back on Earth. Moreover, the pursuit of space travel prompts reflection on the future of our species. As we expand into the cosmos, will we leave behind a planet in disarray? Should our efforts to colonize other worlds come at the cost of neglecting issues here at home, such as poverty, inequality, and climate change? Lastly, a profound ethical dilemma lies in the impact of space exploration on our understanding of humanity's place in the universe. How do we reconcile the search for answers beyond our atmosphere with the spiritual and philosophical questions that arise from it? Exploring the universe is not just a journey of science, but a journey of humanity itself, a balancing act of ambitious exploration, tempered by the responsibilities we hold as custodians of our planet, and perhaps one day, the cosmos. Exploring beyond our universe presents not just an exciting opportunity, but also significant challenges for cosmic preservation efforts. Currently, our efforts focus on understanding and protecting various celestial bodies within our own universe, such as planets, moons, and asteroids. If we were able to explore beyond what we know as our universe, it would open up new realms that could house entirely different types of matter, energy, and possibly life forms. One potential impact of this exploration is the opportunity to gather knowledge and experience that could inform better practices for preserving our own cosmic environment. Discovering how other areas of existence function, thrive, or coexist could provide valuable lessons. For instance, we might learn about alternative ecosystems that have developed in completely different conditions, which could help us understand how to sustain our planet. On the flip side, venturing beyond our universe could also pose risks. If we encounter new materials or phenomena, they could interact negatively with our universe's existing elements. There is the possibility of contaminants from another dimension negatively impacting our cosmic balance, much like alien species introduced into a new ecosystem can disrupt it. Moreover, as we push the boundaries of exploration, there might be ethical considerations regarding our role in the larger cosmos. Would it be our responsibility to ensure that other realms remain untouched and preserved, similar to how we strive to protect endangered species on Earth? This thought prompts us to reflect on our practices and the legacy we wish to leave behind. Ultimately, the exploration beyond our universe would likely transform our understanding of cosmic preservation, highlighting the delicate interplay between discovery and responsibility. The quest for knowledge must always be balanced with the need to protect the wonders we already hold in our universe, guiding our stewardship of the cosmos as a whole. When scientists embark on the journey to explore the universe's limits, they carry a profound set of responsibilities. First and foremost, they must commit to pursuing knowledge with integrity. This means conducting experiments, making observations, and sharing findings honestly, without exaggeration or distortion. The quest for understanding is delicate. Thus, accurate reporting is essential to maintain trust in science and its ability to illuminate the mysteries of the cosmos. Additionally, scientists must consider the ethical implications of their work. As they delve deeper into questions about space, time, and existence, they must reflect on how their discoveries could affect humanity and our place in the universe. For instance, advancements in understanding black holes, genetic manipulation in space, or even the quest for extraterrestrial life can provoke ethical dilemmas. Scientists have a duty to engage with society, educating the public about potential impacts and fostering informed discussions. Moreover, as they develop new technologies and methods to explore the universe, scientists must also prioritize safety. The pursuit of knowledge should never come at the cost of lives or the environment. Whether sending probes to distant planets or studying the energy of stars, they have a responsibility to minimize any risks associated with such endeavors. Finally, collaboration is essential. The universe is vast and complex, and no single scientist or nation can fully unravel its secrets alone. Researchers must work together across disciplines and borders, sharing expertise, resources, and perspectives. This collective approach not only enhances the depth of understanding but also paves the way for innovations that can benefit all of humanity. The responsibilities of scientists probing the universe's limits encompass integrity, ethics, safety, and collaboration. Each of these elements plays a crucial role in ensuring that the pursuit of knowledge is both meaningful and beneficial to our world. The quest to understand the universe's edge, where existence blends into the unknown, may have profound implications for our global resources. This pursuit demands significant investment in technology and research, often driven by national space agencies and private companies. As they develop advanced tools and missions to explore far-off celestial bodies, this technological race can lead to innovations that benefit life on Earth. For instance, The materials and technologies created for space exploration could enhance communications, strengthen data processing capacities, and contribute to renewable energy solutions. Additionally, exploring the universe's furthest reaches raises questions about resource allocation. Scientific funding directed towards space initiatives could draw attention and financial backing away from pressing social issues, such as poverty, education, or climate change. The necessity to balance earthly needs with the ambitions of space exploration is critical. As nations strive to understand the cosmos, they must confront priorities, ensuring that while reaching for the stars, they don't neglect the needs of their own citizens. Moreover, the search for resources beyond our planet, like mining asteroids for rare materials, could alter global economies. If feasible, this could alleviate pressure on Earth's finite resources, potentially leading to new industries and job creation. However, it also brings ethical considerations regarding ownership and the environmental impacts of exploiting off-world resources. Exploring the universe's edge could yield technological breakthroughs that enrich our lives, but also demands careful consideration of how we allocate resources and address earthly challenges, ensuring that one endeavor does not hinder the well-being of humanity on Earth. As we set our sights on the exploration of the universe, ethical principles act as a compass, guiding our actions and decisions. In this vast expanse of unknowns, these principles help ensure that our quest for knowledge is undertaken responsibly and thoughtfully. Central to this exploration is the idea of respect for the celestial bodies we study, for the potential life forms that may exist beyond Earth, and for the very environment of space itself. One key ethical principle is stewardship, which encourages us to take care of our cosmic surroundings. This means considering the impact of our missions on space environments. As we send spacecraft to distant planets or moons, we must avoid contaminating these pristine worlds with Earth microbes. Responsible exploration calls for strict protocols to protect the integrity of these environments, preserving them both for scientific study and for future generations. Another vital aspect is the concept of inclusivity. As we delve into the universe's mysteries, it's important to recognize the diverse perspectives of all humanity. Involving different cultures and communities in the conversation about space exploration enriches our understanding and fosters collaboration. This way, discoveries we make do not only belong to a select few, but resonate with people from various backgrounds, reflecting a collective human spirit. Further, we must anticipate and prepare for the ethical dilemmas that could arise from our discoveries. For instance, if we were to find evidence of life on another planet, the implications would be profound. Such a discovery could challenge our understanding of life itself and raise questions about rights and protection for these life forms. Ethical exploration means we need frameworks in place to address these scenarios thoughtfully. Ultimately, as we explore beyond our planet, our commitment to ethical principles ensures that our journey is not just about seeking answers, but also about doing so in a manner that honors the intricate web of life in the cosmos. By prioritizing respect, inclusivity, and foresight, we can strive for explorations that push the boundaries of knowledge while nurturing a responsible relationship with the universe. Incorporating lessons about the edge of the universe into school curriculums can spark curiosity and expand students' understanding of fundamental concepts in science. To begin, teachers can introduce the idea of the universe's edge by explaining that it is not a physical boundary like a wall, but rather a concept tied to the observable universe, which is the part we can see and study. Lessons could start with basic astronomy, helping students grasp the vastness of space and the evolution of galaxies. Engaging activities like observing the night sky with telescopes or using planetarium programs can foster a sense of wonder about the cosmos. Teachers might encourage students to map constellations, allowing them to visualize their place in the universe. Next, discussions about the Big Bang theory can provide context for how the universe has expanded over time. Educators can explain that as everything began to unfold, light from the most distant parts of the universe took billions of years to reach us, making those regions the edge we can observe. Classroom experiments or simulations that illustrate the concept of cosmic expansion can illustrate these ideas effectively. Integrating technology, such as virtual reality programs that allow students to explore space or software that simulates the universe's expansion, enhances engagement. Students can collaborate on projects that explore topics like dark matter or cosmic microwave background radiation, giving them a hands-on approach to the complexities of cosmology. Class discussions can also include philosophical questions about what lies beyond the observable universe, sparking critical thinking and encouraging students to ponder the mysteries of the cosmos. By fostering creativity alongside scientific understanding, students can develop a well-rounded perspective on humanity's quest to understand the universe's edge. This approach makes learning about the vastness of space exciting and relevant, helping to turn curiosity into knowledge. Online platforms serve as vital tools for spreading knowledge about the vast universe and its intriguing boundaries. Imagine a digital library accessible from anywhere in the world, filled with endless articles, videos, and discussions about cosmic phenomena. These platforms allow experts and enthusiasts alike to share their insights and discoveries, creating a community that transcends geographical barriers. Through social media, educational websites, and video sharing platforms, curious minds can engage with complex topics about space, such as the nature of black holes or the expansion of the universe. The simplified explanations and stunning visuals help break down dense scientific concepts, making them more relatable and easier to grasp for people of all backgrounds. Additionally, online platforms enable real-time discussions. Forums and comment sections encourage interaction, where people can ask questions and receive answers from knowledgeable sources, fostering a culture of inquiry. Live streaming events like lectures from astronomers or chats about recent findings bring these topics to life, making them feel immediate and relevant. Furthermore, the sharing of news about space missions and discoveries allows the public to join in the excitement. When new images from distant planets or stars are revealed, the collective thrill captured online helps to ignite interest and inspire future generations to explore the universe further. Online platforms democratize knowledge, inviting everyone to explore the universe's limits together, closer than ever before. They transform complex subjects into engaging conversations, turning passive viewers into active participants in the quest for cosmic understanding. Interactive workshops can significantly transform how we engage with the topic of the universe's edge. At their core, these workshops provide hands-on experiences that make complex concepts more accessible and relatable. Instead of merely listening to a lecture about distant galaxies or cosmic phenomena, participants can actively explore models and tools that illustrate these ideas in a tangible way. Imagine a workshop where participants can manipulate a globe-like model of the universe, allowing them to visually and physically understand the vast distances between celestial bodies. They could simulate how light travels across those distances, experiencing the delay and challenges that light faces when crossing such expanses. This type of active participation not only makes learning enjoyable, but also deepens comprehension as individuals connect personally to the content. Additionally, collaborative activities within workshops foster teamwork and discussion among participants, enabling them to share ideas and ask questions freely. This exchange of thoughts can spark curiosity and lead to deeper discussions about topics like black holes, dark matter, or the Big Bang. When learners feel they are part of a community exploring these mysteries together, they are more likely to stay engaged and continue their exploration outside the workshop. Furthermore, incorporating technology, such as virtual reality experiences that simulate space travel or allow exploration of cosmic phenomena, enhances the learning experience. Participants can feel as though they are standing on the edge of a black hole or traveling through a nebula, fully immersing them in the wonders of the universe. This kind of engagement captivates the imagination and makes abstract concepts more concrete. Interactive workshops create an environment where curiosity thrives, by empowering individuals to participate directly in the exploration of the universe's edge. These workshops stimulate interest, foster connections, and inspire further inquiry into the vastness of space and its many mysteries. As we look to the future of public lectures on cosmic boundaries, we can anticipate a significant evolution in both format and content. Imagine engaging presentations that go beyond traditional lectures, blending live demonstrations with interactive technology. Audiences could participate in virtual reality experiences, enabling them to explore the vastness of space firsthand. This immersive approach allows people to grasp the scale and complexity of cosmic distances in ways that words alone cannot convey. Furthermore, The use of visual aids, such as stunning graphics and animations that depict the universe's structure, could help illustrate abstract concepts like the cosmic horizon. Presenters might focus on storytelling, using real-life discoveries and breakthroughs in astrophysics to connect with audiences emotionally. For instance, sharing the remarkable journey of telescopes capturing light from the earliest stars could inspire curiosity about our place in the universe. As communication styles adapt, we might also see more emphasis on dialogue and discussion, allowing audiences to ask questions and share thoughts in real time. This interactive format can foster a deeper understanding and interest in cosmic phenomena, making the subject feel more accessible. Additionally, leveraging social media and online platforms could extend the reach of these lectures, bringing cosmic education to a global audience. By creating a dynamic learning environment that combines technology, storytelling, and community engagement, future public lectures can inform and captivate, transforming our understanding of cosmic boundaries into a shared adventure in discovery. Through this evolution, we'll not only explore what lies beyond the edge of our knowledge, but also encourage curiosity about the vast, mysterious universe we inhabit. Science fairs are more than just events. They serve as a crucial stepping stone for young minds captivated by the mysteries of the universe. These fairs ignite interest by providing an interactive platform where students can explore space-related topics in hands-on ways. When young scientists set out to design their projects, they dive into questions about black holes, distant exoplanets, or the origins of cosmic phenomena. This exploration fosters curiosity and critical thinking, crucial traits for anyone aspiring to understand the vastness of space. Moreover, presenting their ideas allows students to articulate their thoughts and share their findings with others. This exchange of knowledge can spark conversations that lead to deeper inquiries. When peers and judges show interest in their work, it boosts confidence and can inspire them to pursue science as a career. Understanding complex subjects, like the life cycle of stars or the physics of gravity, becomes more tangible through personal investigation. Additionally, science fairs often encourage collaboration, where students work in groups. This teamwork emulates real-world scientific endeavors, promoting skills like problem-solving and communication. Engaging with mentors, such as teachers or local scientists, further enriches their experience, allowing learners to gain insights into the current frontiers of space research. By nurturing these interests at a young age, science fairs play a vital role in developing the next generation of astronomers, physicists, and engineers who may one day unravel the secrets at the universe's edge. They provide a foundation that encourages lifelong learning and exploration, ultimately contributing to humanity's quest to understand the cosmos. Exploring the universe's edge invites us to confront some of our deepest thoughts about existence and our place within it. At the edge of our known universe lies the mystery of what exists beyond, areas filled with dark matter, remote galaxies, and cosmic phenomena that challenge our understanding. This vast emptiness sparks a blend of awe and fear, prompting us to consider our insignificance in the grand landscape of the cosmos. When we look into the night sky and think about the mysteries beyond, it often stirs feelings of curiosity. Humans have an intrinsic desire to explore and discover, and contemplating the universe's edge fuels that drive. This quest for knowledge reveals our innate need to understand the unknown and to seek answers to questions that have puzzled us for centuries, such as where we came from and where we might be going. Additionally, exploring this frontier forces us to grapple with the aspect of time. The vastness of space means that many astronomical phenomena happen over incredibly long periods, which can make our human lives seem fleeting and transient. This contrast leads to reflections on mortality and purpose. How we choose to spend our limited time affects how we perceive the universe and our role in it. The emotional responses tied to astronomical exploration can also foster a sense of unity among people. When we catch glimpses of the universe's grandeur, it can create a feeling of shared experience, reminding us that, despite our many differences, we are all part of the same cosmic story. This collective journey into the unknown can inspire cooperation and collaboration as we realize that the mysteries of the universe transcend individual borders. Delving into the universe's edge serves as a mirror for our psychology, reflecting our curiosity, our fears, and our yearning for connection. It challenges us to think about what it means to be human in a universe that is both beautiful and bewildering. The journey into this vast unknown encourages us to stretch our minds and hearts, inviting us to embrace not only the wonders that lie ahead, but also the inner struggles that make us who we are. When we begin to think about the universe's boundary, our minds undergo significant cognitive shifts that challenge our understanding of reality. First, we must confront the idea of infinity. Most of us are accustomed to thinking in terms of the concrete and the finite, a limited space where we can navigate and measure distances. Considering an infinite universe pushes us to abandon these everyday measures and contemplate a vastness that seems impossible to fully grasp. Next, we often find our perspective expanding. Instead of viewing our world as the center of existence, we start to see ourselves as part of a much larger tapestry. Imagining ourselves amid galaxies, stars, and cosmic structures encourages a sense of connection to the universe. This can evoke both humility and wonder as we realize our place in the grand scheme of things. Moreover, we encounter the concept of the universe's shape, whether it is flat, curved, or follows some other geometry. Each possibility comes with different implications about the universe's fate and what might lie beyond our current knowledge. This line of thinking forces us to reconcile our scientific understanding with philosophical questions about existence and reality. Additionally, contemplating the boundary of the universe often leads to questions about time itself. If the universe had a beginning, what existed before it? What will happen if it continues expanding forever? Such questions can challenge our notions of cause, effect, and linear progression, pushing us to explore ideas that may feel paradoxical or contradictory. Ultimately, these shifts in thinking about the universe's boundary can lead to a deeper sense of curiosity and a desire to explore further. They remind us that as we learn more about the cosmos, we also uncover the limits of human understanding and the scope of our imagination, leading us to contemplate possibilities that stretch far beyond our current reality. Studying the universe's edge can present a range of psychological challenges for scientists and thinkers alike. When contemplating the vastness of space, individuals may grapple with feelings of insignificance. The immense scale of the universe can lead to existential questions about humanity's place within it. This sense of smallness, while humbling, can also provoke anxiety or even despair for some. Moreover, the sheer complexity of the universe's mysteries can cause frustration. Researchers may encounter concepts that defy current understanding, leading to feelings of helplessness in the face of the unknown. The more one learns, the more it can seem like there is an overwhelming amount yet to be discovered, which can foster a sense of being lost in the vast web of knowledge. Isolation is another psychological challenge. The universe's edge is a topic that can feel distant and abstract, making it difficult to share one's thoughts and feelings with those who may not have the same understanding or interest. This disconnection can intensify feelings of loneliness, particularly for those deeply immersed in the subject. Additionally, the pursuit of knowledge about the universe's edge can impact an individual's worldview. Encountering concepts like the possibility of a multiverse or the end of the universe can challenge previously held beliefs about existence and reality. For some, this can lead to moments of cognitive dissonance, where new scientific ideas conflict with deep-seated personal beliefs. Finally, the use of imagination required to grasp the edge of the universe can lead to intense mental fatigue. This type of deep thinking and visualization demands much from the mind, potentially leading to burnout if not balanced with periods of rest and recreation. Understanding the universe, especially its boundaries, takes more than intellect. It also requires emotional resilience and the ability to process both wonder and uncertainty. The universe stretches out infinitely in all directions, and contemplating its vastness can evoke a profound sense of wonder. This feeling, sparked by the enormity of space and the mysteries it holds, can have significant effects on our mental health. When people reflect on the stars, galaxies, and the endless possibilities beyond our planet, they often experience a shift in perspective. This change can lead to feelings of awe and connection, diminishing feelings of isolation or insignificance that many might struggle with. Experiencing wonder can enhance our emotional well-being. It can foster a sense of belonging to something much larger than ourselves, grounding us in a shared human experience. This connection to the cosmos may encourage feelings of hope and curiosity, prompting individuals to seek answers about their existence and the world around them. Such engagement can lead to increased creativity and motivation, further improving mental resilience. Additionally, the act of gazing at the night sky can serve as a natural form of mindfulness, providing a break from the stresses of daily life. It invites a moment of reflection, allowing individuals to step back and view their problems from a greater distance. This shift can help to alleviate anxiety and negative thinking, offering a sense of peace and clarity. Ultimately, the awe inspired by the universe's boundaries can cultivate a deeper appreciation for life itself. It encourages individuals to explore, ask questions, and find meaning in both the vast unknown and in their everyday experiences. This ongoing journey contributes positively to mental health, nurturing a sense of wonder that is essential for personal growth and emotional well-being. Curiosity about the universe's limits is a powerful driver for cognitive development. When we ponder questions about the cosmos, we engage with concepts that challenge our understanding of reality. This sparks a deep sense of inquiry that pushes us to explore not just the vastness of space, but also the foundations of our thinking. As we seek answers, we learn to interpret complex information, evaluate evidence, and think critically. For example, wondering about what lies beyond the furthest galaxy encourages imaginative reasoning and hypothesis formation. This process stimulates mental agility, allowing individuals to connect abstract ideas with logical reasoning and scientific principles. Furthermore, discussing and grappling with the universe's mysteries can lead to greater emotional engagement, as wonder and awe can inspire creativity. Such feelings prompt exploration in various fields, including science, philosophy, and art. As curiosity evolves into deeper understanding, it nurtures skills like problem-solving and adaptability. Each question leads to new inquiries, providing an endless loop of learning that sharpens the mind. Ultimately, the act of exploring the universe's limits is not simply about answering cosmic questions. It's about choosing to engage with the unknown. This journey fosters critical thinking, creativity, and a continually expanding worldview, enriching our cognitive capabilities in profound ways. Several emerging technologies have the potential to significantly enhance our exploration and understanding of the universe's edge. One of the most exciting developments is in the realm of advanced telescopes. These new instruments are being designed to observe distant cosmic objects with unprecedented clarity. By gathering light from the farthest reaches of space, they might reveal details about galaxies, black holes, and the overall structure of the universe that we have never seen before. Another groundbreaking area is the use of artificial intelligence. AI can analyze vast amounts of data collected from observatories and space missions much faster than humans can. By spotting patterns and anomalies in data, AI can help scientists identify new celestial phenomena or even predict cosmic events, deepening our comprehension of what lies beyond our current observations. Moreover, advancements in spacecraft technology promise to extend our reach into the cosmos. With the development of faster and more efficient propulsion systems, future missions could travel to distant planets and moons much quicker than ever before. This means we might send probes further out into our solar system or even beyond, gathering first-hand data about the universe's outer edges. Additionally, the advent of quantum technologies holds enormous promise. Quantum communication, for example, could enable us to transmit information over vast distances with near-instant clarity, allowing for real-time data sharing from instantaneous cosmic observations back to Earth. Finally, the study of gravitational waves, the ripples in space-time caused by the movement of massive objects, opens up a new way to observe the universe. As detectors become more sensitive, we may glean insights about events occurring at the very edges of the universe, such as colliding black holes or neutron stars, revealing secrets about its structure and evolution. Together, these technologies not only promise to refine our current understanding, but could also unlock entirely new realms of knowledge about the universe's edge, reshaping what we know about our cosmic environment. Each advancement pushes the boundaries of our exploration, leading to a deeper and more intricate picture of the universe we inhabit. As humanity continues to advance, the concept of the universe's boundary may evolve significantly. Currently, We understand the universe as having no tangible edge. It expands endlessly. Future civilizations, equipped with a deeper grasp of cosmology, might view the universe's boundary not as a physical wall, but as a limit of comprehension. They could conceptualize it similarly to how we perceive the horizon on Earth, a point where we can no longer see beyond, but which doesn't signify an end. With the development of advanced technologies and space exploration, these civilizations might propose theories suggesting that what lies beyond this perceived boundary could contain other dimensions or realms, leading to thoughts that our universe is just one bubble in an enormous ocean of universes. This could inspire philosophical and scientific discussions about the nature of existence itself and whether we are just part of a much larger cosmic tapestry. As they explore the universe, they may also realize that the boundary represents the limits of observable space. They might recognize that moving faster than the speed of light isn't just a physical impossibility, but also a barrier to experience and knowledge. In their endeavor to understand dark matter and dark energy, they may discover that the universe's boundary is an illusion created by the way light travels and how time functions. Ultimately, future civilizations might find themselves not just confronting a limit, but embracing the mystery of the universe, viewing the boundary as an invitation to explore rather than a confinement. This perspective could lead to an appreciation of the journey of discovery, as they continuously seek to push the boundaries of their understanding further, revealing whether the universe has an end or is just part of a boundless cosmic adventure. The fate of the universe is a topic that fascinates scientists and thinkers alike, delving into ideas that stretch the imagination beyond observable reality. We often picture the universe expanding outward, but what lies beyond its edges is speculative and theoretical. One scenario suggests that the universe could continue expanding forever. As it does, galaxies will drift farther apart, and eventually the light from distant stars may fade away. This could lead to a dark, cold expanse where only the faintest remnants of energy linger. This theory is known as the heat death of the universe, where all matter and energy reach a uniform state, resulting in no motion or complexity. Another possibility is known as the Big Crunch, where the expansion of the universe might someday reverse. If gravity pulls the matter back together, it could culminate in a cosmic collapse, potentially leading to a singularity where all the universe's mass is concentrated again. This scenario raises the intriguing question of what might happen next. Would the universe emerge again in another Big Bang, creating an endless cycle of expansion and contraction? There's also the idea of multiverses, suggesting that our universe could be just one of many. Beyond the observable universe, other universes could exist with different laws of physics, dimensions, or even timelines. This concept opens the door to a multitude of realities where each universe expands its own way, with some possibly collapsing, merging, or existing alongside others. Lastly, some theories propose that the universe could simply reach a state of maximum entropy, where everything becomes so spread out that individual atoms and molecules drift apart, and time itself might lose its meaning in this vast cosmic wilderness. While these scenarios are purely speculative, they inspire us to think deeply about existence, time, and the cosmos's profound mysteries. Each of these possibilities invites us to explore questions of reality and invites imagination beyond the known universe. The ultimate fate remains uncertain, but the quest to understand it encourages humanity to gaze beyond the stars. Discovering the universe's edge, or the limits of our observable universe, could fundamentally change our understanding of humanity's place in the cosmos. Although we often think of evolution as a biological process occurring over millions of years, shifts in knowledge can influence the way we perceive ourselves and adapt to our environment, both intellectually and culturally. If we were to uncover new information about what's beyond the observable universe, it might inspire innovations in technology and spark new fields of research. Imagine a world where scientists were able to create advanced means of space travel. This could open up entire new realms for exploration, perhaps leading to the colonization of other planets or even interactions with extraterrestrial life. Such opportunities could encourage a shift in our evolutionary path, pushing humanity to adapt to entirely different environments and ways of living. Furthermore, understanding the universe's edge could lead to philosophical and ethical transformations in how we view our species and each other. Realizing we are part of a vast, possibly infinite universe may foster greater unity among people, prompting a collective evolution in empathy and cooperation. This fresh perspective could encourage us to work together to solve pressing challenges like climate change or resource scarcity, as we recognize our shared existence on a fragile planet. Moreover, as we expand our understanding of the universe, we might also develop new technologies that enhance our cognitive and physical abilities. Advancements in genetics, artificial intelligence, or even virtual reality could intertwine with our quest for knowledge, leading to an evolution in how we think and experience life. The edge of the universe symbolizes not only a physical boundary, but also the forefront of human curiosity and exploration. With every discovery, we step closer to understanding our origins, our future, and the potential pathways of our evolution, both as individuals and as a species. Thus, the journey at the edge of the universe could drive a transformative shift in how humanity evolves, adapting not just biologically but also culturally and intellectually as we reach for the stars. Scientists and artists both dream of what lies beyond our current understanding of the universe, crafting visions that inspire curiosity and wonder. Many scientists believe the universe might be infinitely vast. They explore concepts of an expanding cosmos, where galaxies move away from each other, like dots on a balloon being blown up. This idea leads to questions about what exists at the very edge of space. Some theories suggest there could be more galaxies, forming a network of universes, each with its own distinct physical laws. This notion is known as the multiverse theory and invites speculation about dimensions beyond our perception. Artists, meanwhile, harness imagination to portray these cosmic frontiers. They envision intricate, colorful landscapes filled with celestial bodies, and they often reflect the unknown wonders that may exist. Their creations can depict spaces filled with swirling nebulas, strange planets with unique atmospheres, or entire civilizations thriving in the void of space. These artistic interpretations remind us that science hasn't exhausted the boundaries of creativity when seeking to illustrate what might be possible. Both fields collide in an exciting way, as artistic visions can inspire scientific inquiry, while scientific discoveries can lead to new artistic concepts. The collaboration shows how exploring the universe's boundaries means not only pushing the limits of what we know, but also engaging our imaginations. This shared fascination underscores a basic human drive to understand where we come from and where we might go, keeping our eyes fixed on the stars, whether through lenses or through art.